We are giving importance not for mathematical calculations, but the concepts that is employed or applied to get the solution. Estimate maximum error eta, sorry. So, we have to convert that into eta equation. Sorry, eta. From this eta is equal to 2 by 9 r squared rho minus sigma into g by v sub. It's okay. Now we can neglect the error. There is no error for these quantities. No error at all. And therefore error is for r and v sub. C here is 2 and here is C1. But therefore no need of, to save time I am telling, there is no need of taking B4 because in these two probable options you can see that B connected to 4, but that is true. Good day, my dear friends. This is Prof. Thomas and Chaithanya Classes. Here in this video, we are going to discuss the last session JEE Main physics questions, chapter-wise questions. And in this video, we are concentrating the first two chapters. They are units and dimensions and kinematics. We are giving importance not for mathematical calculations, but the concepts that is employed or applied to get the solution. Now come to our very first question that is on the board. It is not like this. The time period of a simple harmonic oscillator is t is equal to 2 root of k by m. Measured value of m of the object is 10 gram with an accuracy of 10 milligram. Time 50 oscillations of the spring is found to be 60 seconds using a watch of 2-second resolution. Percentage error in the determination of spring constant. Now what we have to do, very first, you know that this is the problem from arrays. And we have to get an expression for k first. We are given the time period equation. From this, we have to get the expression for k. Now, doing this k is equal to squaring. K square is equal to 4 pi square k by m. From this k is equal to mt square by 4 pi square. Now this is the expression for k. And here, measured value of m, 10 gram. And therefore the quantum value of the mass, you can write like this, 10. And with an accuracy, 10 milligram. 10 milligram means you have to convert that into gram. And that is equal to plus or minus 10 milligram is equal to 0.01 gram. Now this is the quantum value of mass. And time period of 50 oscillations of the pendulum is found to be 60 seconds using a batch of 2-second resolution. And therefore, the time period you can write like this. Time for one oscillation, t is equal to 60 seconds for 50 oscillations. 60 by 50. 6 by 5 equal to 0.2 seconds. And its absolute error. Here the resolution of the watch is 2 seconds. That 2-second resolution is distributed over 50 oscillations. Therefore, delta t is equal to 50 oscillations, error is 2 seconds. 2 by 50 is equal to 0.04 seconds. Therefore, quarter value of time, you can write like this is equal to 1.2 plus or minus 0.4 seconds. Now we obtain the quarter value of mass and time period. Then what is the percentage of error in percentage of deterministic constant? So from our theory, you know, percentage error in K is equal to percentage of error in M plus percentage of error 2 into applying power rule 2 into percentage of error in T. So the quarter value must be represented in percentage of error. Now it is in absolute error format it is written. Therefore, this can be converted into percentage of error like this. M is equal to 10 plus or minus 0.01 by 10 in the 100. Is equal to 10 plus or minus 0.1 percentage. Similarly, time period you can convert it into percentage error. T is equal to 1.2 plus or minus 0.4 by 1.2 in 100. This on calculation is equal to 1.2 plus or minus, this is equal to 3 4 by 1.2. 4 by is equal to 12 1.2 plus or minus 3.6 percentage. Now substitute here. So what is the percentage error in K? Percentage error in K is equal to percent error in M is equal to 0.1 plus 2 into 3.6. And this calculation, on adding, you get the value is equal to 6.76. Properly, and the value is found to be 4. Next question we shall go. Now, the mathematical step that we did, that is there on the board again. In an experiment, a set of reading is obtained 1.24 millimeter, 1.25, 1.23, 1.21, and the expected least count of the instrument using recording these readings. Now you can see that here the least count is equal to 1.24 and the least count is equal to 0.01. Limited. Next one you can see that there are 2 decimal places and therefore the least count is again 0.01. Next one, 2 decimal places, least count is 0.01. Next one also you can see 1.21 and therefore the least count is equal to 0.01. And therefore the instrument that you used to measure all these reading is equal to 0.01 millimeter. So the answer is this one. Explanation is so simple. Go to our next question. Here the column matching and the problem you can see magnetic induction, magnetic flux, and magnetic permeability and self-inductance. Now, we have to write down, we cannot remember all the dimension formula of these by heart. So we have to derive and get the answer. That's okay. Now get the magnetic induction B. You know Lorentz force is equal to F is equal to PQV. Therefore, B equal to F by Q. Force M L T minus 2 by charge I into T. Velocity L T minus 1. And this on simplification. This will cancel out. M. This will cancel out. T minus 2. L raised to 0. This one. Now M L raised to 0, T raised to minus 2, A minus 1. This is the answer. So A to 3. Now at once you can see that here, the very first question, the first A is related to or connected to 4. There are A4. No, A connected to 3. A connected to 3, there are two options, 1 and 4. Therefore, now we have to verify whether this one is correct or this one is correct, because this is already found out. Now go to our second B. B4 in these two. C here is 2 and here is C1. But therefore, no need of, to save time I am telling, there is no need of taking B4, because in these two probable options, you can see that B connected to 4. But that is true. Next one, C2 or C1. Magnetic permeability. Now you can write any equation to get the magnetic permeability. You already got the value of B. You know energy density in magnetic field, energy density. Energy density has got the same unit as that of pressure. That is also known to you. Energy density is equal to B square by 2 mu 0. So mu 0 is equal to, from here, mu 0 equal to B square by energy density. B already you got. B square M T minus 2 L 0 T minus I minus 1 whole squared by energy density same as pressure. Pressure M L minus 1 T minus. Force by area. By M L minus 1 T minus 2. Simplify this. Here you can see that M square M T raised to minus 2 T raised to minus 2 minus 4 minus 2 L raised to minus 2, and that is mu. Now whether that is connect B is, I'm sorry, third one, C, 2 or 1, M L T minus 2 A minus 2 I minus 2, that means A minus 2. So this is connected like this. So C is connected to 1. C is connected to 1. Therefore, the option is C is connected to 1, option is 4. Oh, you are here we verified only 2 options. Even though we have to verify 4, we did only 2 and we arrived at the result. So we can save time. Okay? Yes. Next question. Match the list 1 with the list 2. Here we can see that radio waves generated by how they are produced. They are produced due to the acceleration, rapid oscillations, rapid acceleration of electrons, and how the radio waves are generated in antenna, that is rapid acceleration of the electron. Microwave produced by A, we can say that A connected to 4. A connected to 4 as we did earlier. A connected to 4, here also 4, here also 4. Well, there are 3 options. Now come to B. B, in this option is 1, here 3 and this is 2. And therefore, we have to verify B1. B, microwave. Microwave is generated by the magnetron bulb. And there is 1. B1. And there is no other option like that. And none of this is not there. And therefore, here we can stop because this is our answer. And second one, infrared radiation are generated by the change of vibration mode of atoms and X-rays. And they are inner transition of the electrons. Well, that may be one of the reasons, or fast moving electron when suddenly stop, X-rays are produced. That is the other option. Here, these are the way these waves are generated, and therefore our option is equal to 1. Now, a ball of radius r and density rho is dropped through a viscous liquid, or density sigma and viscosity eta, attains its terminal velocity at a time t, given by function is there, where a is a constant, a, b, c, and d are integers. The value of b plus c by a plus d is. That means we have to evaluate the value of a, b, c, and d. If you opt for homogeneity concept, definitely so tedious and time consuming. Therefore, we are not opting homogeneity concept. Instead, we are going to generate a non-equation, or we have to generate an equation for this t in terms of these parameters, density, r, eta, and sigma, from our knowledge. You know, when a body is dropped through a viscous liquid and attain terminal velocity, when the terminal velocity attained, weight is balanced by the viscous force, neglecting the other terms, we can say. The buoyant force, etc., if you neglect. Now, the dropped through a viscous liquid and the viscosity attained terminal velocity at a time t is given by. T, given equation is like this. A rho raised to A, R raised to B, eta raised to C, sigma raised to D. Now, the terminal velocity equation, a ball radius or density rho dropped through viscous liquid, attain terminal velocity. The terminal velocity equation is given by 2 by 9 r squared rho minus sigma. Equations, general equation I'm writing. By 8. And in our equation, you can say that radius is the velocity is the thermal velocity is the time is not at all involved. Time is not at all involved there. But when a body drops, it attains terminal velocity. How? Weight is balanced by the viscous force. And therefore, instead of like this, we can write mg is equal to 6 pi eta RV roughly. mg is equal to 6 pi eta RV. From this, V is equal to mg, V is equal to mg by 6 pi eta R. Here the density of the body is given instead of using this one. So this can be given like this 4 by 3 pi R cube, volume of the body, into density of the body. Ball of radius R and density rho. G by 6 pi eta R. And G, the velocity. G, the acceleration. Acceleration is equal to velocity into time. This can be written as velocity into time. And therefore, we can write like this: V is equal to 4 by 3 pi R cube rho velocity into time by 6 pi eta R. From this, T is equal to, from here, T is equal to, these are constants. We are not bothered about the constants. And therefore, we can say that T proportional to eta R by R cube rho. This is proportional to eta R raised to minus 2 or R raised to minus 1. Here you know now T is equal to a constant by A, some constant A. Rho raised to minus 1. R raised to minus 2. Eta raised to 1. Sigma raised to 0. Now compare. Compare, you can say A is equal to minus 1. B is equal to minus 2. C is equal to 1. D equal to 0. Now B plus C. B plus C mean minus 2. B plus C, minus 2 plus 1. Modulus bar is equal to 1. By A plus D or minus 1. See, we can say minus 1 plus 1. So it's equal to our answer. Therefore, B plus C by A plus D equal to B minus 2, C plus 1 by minus 1 plus 0. Equal to minus 1 by minus 1 is equal to 1. Therefore, our answer is equal to 1. So here the answer is equal to 1. Rather than apply homogeneity, we approximately generated a similar equation from our knowledge and get the answer. Okay, next question. Now, four person measure the length of a rod. The relative error in the measurement of average length of the rod. That means what we have to do, the principle is that we have to find we have to add up all and get the mean value and mean deviation. From this, mean absolute error is found out. Get the answer, that's okay. Now, the mathematical part, we added all of them and take the average. Average is about 18.75. Then absolute error, the modulus of difference between each value with the mean value, and that is found out for each value. And they are added, and their average is found out. And the average is found to be 1.12. Then relative error, mean absolute error by mean value. So 1.12 by 18.75, the value is found to be 0.0597. And round off is equal to 0.06. So that is our answer. So the answer is equal to 2. Very simple mathematical steps required for getting this solution. Next one. Again, match the list 2 and 1. We have to match. Similar problem we did earlier. 2 questions we did. Similar problem again comes. Now, spring constant. Spring constant mean spring constant again. Force by length. It's called M T minus 2 by L. It's equal to M Thrissur T raised to minus 2. M L0 T minus 2. M L0 T minus 2. A connected to 2. A connected to 2. How many options are there? See. Now, this one and this one. Now we have to verify only this. We can neglect the other options. In the second one, there is B is equal to 1. In third one, B is equal to 4. So we have to go to thermal conductivity, B. Thermal conductivity, K. Again, heat conducted per second, heat power. Heat conducted per second or Q by T is equal to Ka d theta by dx. From this thermal conductivity, K is given by Q energy into dx by energy into dx by time into area into temperature difference. Substitute the dimension formula of each energy M raised to 2 T minus 2 dxL by T L square area d theta K. Okay. This is not simplification. This is not simplification. M square will cancel out. Here there is one L, M, L. This will cancel out. T raised to minus 3. K raised to minus 1. M, L, T minus 3, K minus 1. M, L, T raised to minus 3, K minus 1. That is 4. So B connected to 4. B connected to 4 means this one. Now our competition between 1 and 3 and this one verified. And therefore that is our answer. So the answer is 3. Question number next one. Keeping the significant figures in view, some of the physical quantities we are given. You have to add all of them. And what is the rule that you have to apply? Since addition containing decimal point, the result must contain the minimum number of decimal point in the component. There is a rule. Now here, 2 decimal points are there. 52.01. 2 decimal point positions. Next one, 153.2. Only 1 decimal place. And next one, 0.123 in 3 decimal places. The answer is, we have to add all of them. Simply add up, and finally in the decimal we have to keep only 1 after rounding off. Now going through our options, you can say that here there are 3 decimal places, 1, no decimal place 3. Definitely this is the one, because the result must contain only 1 decimal place. So the answer is second one. Next one. A spherical body of radius r at density sigma fall freely through a viscous liquid having density rho and viscosity eta in terms of velocity. Estimate maximum error in the quantity eta. Ignore the error associated with sigma, rho, g, gravitational acceleration, etc. Now, you have to write down the formula first of all, containing what? Thermal velocity, spherical body falling out, density sigma fall through freely, a viscous liquid having density rho, velocity attain thermal velocity V0. Now, what is the formula for V0? We already wrote down V0 is equal to by 9 r squared rho minus sigma into g by eta. Now here, ignore the error associated with the sigma rho. No error is there for sigma, no error is for rho and g. Therefore, the depending parameters in which error are there, it is r and estimate maximum error eta. Sorry, so we have to convert that into eta equation. I'm sorry, eta. From this, eta is equal to 2 by 9 r squared rho minus sigma into g by V0. It's okay. Now we can neglect the error. There is no error for these quantities. No error at all. And therefore, error is for R and V0. Therefore, percentage error in eta is equal to, apply with the power rule. This means the maximum error is equal to, your relative error is asked. Relative error in eta, that is delta eta by eta. That is the relative error in eta is equal to power times 2 into delta r by r plus delta V0 by V0. For getting maximum error, we always the relative error, and that is what we did. 2 into delta r by r plus delta V0 by V0. And see the option. 2 delta r by r plus delta V0 by V0, that is option 1. To get the maximum error, we have to always add up the error. It's okay. And also we apply the power rule. Next question. Question is like this. In an experiment, the values of 2 spring constants were measured. K1 is given and K2 is also given. And the data given, the quoted value given in mean absolute error format. If these springs are connected in parallel, then the percentage of error equal to spring constant. Now, when springs are connected in parallel, the effective spring constant is given by in parallel K1 plus K2. Therefore, the quoted value of effective spring constant, substituting, get 10 plus or minus 0.2, 20 plus or minus 0.3. It's on addition. And what is the rule? Mean value is added as part of the operator. That is adding 30 plus or minus. Mean absolute per error part is always added up. It's called point. And here convert that into percentage error. And what is the percentage error? 0.5 by 50 into 100. Cancel out 5 by 3. 5 by 3 mean 1.67%. 30 plus or minus 1.67%. The option is, and here what is asking? We are asked to find only the percentage error. It's equal to 1.67. The option is equal to 2. Yes, this is the option. Next question. Consider a modified Bernoulli's equation. P plus by bt square plus rho h plus bt plus RB0 square is a constant. If the dimension of time, if T has got the dimension of time, the dimension of A and B, dimension of A and B that you have to find. Now, applying the fact that here you can say these two are added up, which is the height, Bernoulli's equation, which is the height, and with the h, bt is added up. Therefore, dimension of h and dimension of bt are the same, or b equal to h by t. The dimension of b and dimension of bt and h are the same because they are added. Quantities having same quantity dimension formula can be added. From this, b is equal to h by t. H is the height, length is equal to L t minus 1. M0, b is equal to M0 LT minus 1. B M0 LT minus 1. And how many are there? M0 LT minus 1, M0 LT minus 1. This is correct. This is also correct. Now we have to verify this only, 1 and 2, because these are wrong. Now next we have to find the value of A. We already got the value of B. Applying the same principle here, that is, P is added with the pressure, added with the A by BT square. Therefore, A by BT square has got same dimension as that of P. A by BT square same as P, because they are added. Dimension formula is same. From this, A is equal to P BT square. P, you know the pressure, M L minus 1 T minus 2. B already we found out. B is equal to L T minus 1 T square. Simplifying, M L raised to 0 T raised to minus 1. M L raised to 0 T raised to minus 1. Definitely one is that. So that is the options. Okay. Now there are 11 questions from this chapter. Units and dimension. He must opt least time mode for this study. Least time mode. Least time mode means he must always swim perpendicular to the flow. But due to the velocity of the river, he drift. What must be the velocity? The velocity when the body retains the extreme or turning point, the velocity must be 0. So we have to find out at what time velocity becomes 0. To find out that time, then substitute in this equation. This is the position of the fourth one. This is the position of the third one. And this is the position of the second one. Say, Now we took a photograph of these drops. First drop, second, third, fourth, fifth, sixth one. Next, we shall go to our kinematic chapter. Next chapter. A particle start moving from t is equal to 0 and its coordinate is given as xt is equal to 4tq minus 3t. And we are asked to find out the behavior of that particle at the different instances. That's okay. We are given the function displacement equation. This is position equation xt is equal to 4t cube minus 3t. The particle returned to its original position in 0.8 unit later. Particle returned to its original position means displacement must be 0. Now our aim is to find at what time the displacement is 0. Now we are given the displacement equation x of t is equal to 4t cube minus 3t. Now when it retains xt is equal to 0 and the 0 is equal to 4t cube minus 3t, t into 4t square minus 3 equal to 0. That means 4t square minus 3 is equal to 0 or 4t square is equal to 3. T square is equal to 3 by 4 or t is equal to root of 3 by 4. And that value on calculation is roughly 0.86. 0.75 is root of 0.75 is equal to 0.866. And you know that is our first statement. Particle returned to original position after time. So this one is correct. Way is correct. Now there are 4 options in which they are correct. There are 3 options. We have to verify the other one also. Now the particle in unit time, 1 unit away from origin at its turning point. The particle is 1 unit away from origin at its turning point. Now that can be done, turning point, in 2 ways. You know, the particle 1 unit away from origin at its turning point. At turning point, what must be the velocity? The velocity when the body returns at the extreme or turning point, the velocity must be 0. So we have to find out at what time velocity becomes 0. And find out that time and substitute in this equation, x equation, we get the position where it returns. Got the point? Therefore, we have to see at the turning point velocity is 0. Therefore, we have to get the velocity function. Velocity function is equal to x by dt. Velocity v is equal to dx by dt. Velocity function is equal to differentiating 12 t square minus 3. 12 t square minus 3. And at the turning point, this is equal to 0. 12 t square minus 3 is equal to 0 or t square is equal to 3 by 12 is equal to 1 by 4 or t is equal to 1 by 2, 0.5 second. The body retained at 0.5 second. Is that option is there anywhere? That is not there. Now we have to say at that time, what is the value of xt? Now substituting at this time, x the turning point, x turning point, x at a time 0.5 is equal to 4 into 0.5 whole squared minus 3 into 0.5. Sorry. T cube. minus 3 into 0.5. That is the position, the value of x at the time 0.5 second. That on calculation give you the value 1. This on calculation, the value is equal to 1. That means the particle is 1 unit away from origin at its starting point. So B is correct. B is correct. If B is correct, the particle is 0.5 unit away from origin at its starting point is wrong. This is wrong. Acceleration of the particle is non-negative. Next one. Particle never turn back as acceleration is non-negative. Particle never turn back as the acceleration is non-negative. We found that there is a position from where the body returned, and therefore definitely this statement is wrong. But now we have to see whether acceleration of the particle is non-negative. To get that, we got the velocity equation. Velocity equation is this one. Then what is the acceleration equation? Acceleration is equal to dv by dt. That on calculation is equal to 2040. 2040. Equal to 2040. And t never be negative, and therefore acceleration never be negative. Never be negative. The acceleration of the particle is non-negative. This statement is correct. Therefore, we can say that A, B, C are correct. So option is equal to 4. Okay. Go to our next question. Water drops fall from tap on a floor 5 meters below at a regular interval of time. The first drop strikes the floor when the sixth drop begin to fall. The height at which the fourth drop will be from the ground at the instant when the first drop strikes the ground is. Now this is the position from the drops, and this is the ground, and the height is equal to 5 meters. Now we are going to take a flash photograph of the situation. That is, the first drop is here, 1 minute. Sixth drop is here, and this is 5 meters. Sixth drop just going to release, the first drop hit here. Then this is the position of the fifth one. This is the position of the fourth one. This is the position of the fourth one. This is the position of the third one. And this is the position of the second one. Say. Now we took a photograph of these drops. First drop, second, third, fourth, fifth, sixth one. And the problem says the sixth just going to release. First one hit the ground, and separation between them is a meter. Now apply at a regular interval they are dipped, and therefore you can apply the Galilei law, odd numbers. In equal interval of time, the displacement are in the ratio 1:3:5:, etc. And therefore, if this is x, this is 3x, this is 5x, this is 7x, this is 9x. 1:3:5:7:9. Galilei law of odd numbers. Add up x plus 3x plus 5x plus 7x plus 9x. Give you the separation between first and sixth, that is equal to 5 meters. Adding 16, 21, 24, 25. 25x is equal to 5 meter. So x is equal to 5 by 25, 1 by 5 meter. That is the value of x. Now what is the question? The height at which the fourth drop will be from the ground at the instant when first drop. This height. This is the fourth one. And what is this height? That height from here is equal to 9x plus 7x plus 5x. So our answer is 9x plus 7x plus 5x is equal to 21x. Equal to 21 into 5 by 1 by 5. 4.2 meter. So the answer is 4.2 meter. Rather than applying half GT square, etc., we can directly apply the Galileo of odd number and get the answer quickly. Okay. Velocity v, distance x, graph is shown in figure. The graph represents the acceleration versus distance x, variation of the system. Now we are given velocity x graph. You can see there is a straight line with the positive y-intercept, negative slope. And hence, you can write down the general format or equation of velocity connected with x. But the equation generally represented y is equal to, v is equal to, minus, because slope is negative, slope minus slope into x, plus y-intercept. Y-intercept, say this is equal to v0. This point is v0, we can say v0. This is the equation of this graph. Minus, and the value of k, if you want, you can get the value of k also. K is equal to v0, this is x0. Then k is equal to y by x, v0 by x0. If you want, you can write like this. But we are keeping that k itself, where k is the slope, negative slope. This is v. Then, if you differentiate, what is dv by dx? dv by dx is equal to minus, that is slope of this equation. That is dv by dx. Now, why we are doing all this? Because we are asked to find acceleration versus distance. Acceleration versus distance, A and acceleration. You know A is equal to, acceleration A is equal to, equation is equal to dv by dt, or v into dv by dx. This is the formula for acceleration. V into, in terms of x, v into dv by dx. Therefore, A is equal to v into dv by dx is already there with us. Minus k. V already there with us. Substitute here. So minus kx plus v0 into, that is our v. dv by dx is equal to minus k. Equal to k square x minus k v0. That is acceleration. This is the acceleration equation. Acceleration equation, you can see that again, the constant depend on x, but there is a linear graph. Slope is positive, k square. Slope is k square. And y is intercept is negative. Y-intercept is negative. That means straight line, positive slope, negative y-intercept. Go through this and get the option for that. Now this is the graph in which you can say that positive slope, negative y-intercept, and therefore this is our option. So option is equal to 4. It's okay. A boy throw a ball into air at 45 degrees from the horizontal to land it on the roof of a building of height h. If the ball attain maximum height 2 seconds, land on the building 3 seconds after the launch, the value of h is, where h is the height of. Now we can, so this is the path. The body thrown at an angle 45, went up the maximum height and reached. Here is our building. is the building. Reached here like this. This is the building. And what is ours? The value of h. What is that? The building of height h. So we are asked to find what is this h. Height of the building. And the ball is thrown at an angle 45 and on the roof of building of height h. If the ball attained maximum height 2 seconds. To reach here, it took 2 seconds. Problem is that body projected at an angle 45 reach the maximum height in 2 seconds. Then from there, it reaches here. It reached around the building. That's okay. Then, what is this h? Suppose we can calculate this height. That's the maximum height of the projectile. And suppose we can calculate this height. Then h is equal to this minus this. That's okay. What is this? We are given the what is the time taken by the body to reach the maximum height? It is given 2 seconds. Then it is symmetric, and therefore, what is the total time of flight of this body? 2 seconds to reach the highest point, 2 seconds to return back, 4 seconds. The time of flight of this body, time of flight is equal to 4 seconds. If time of flight is given, you can calculate the vertical height reached by the projectile. Time of flight is given. The vertical height, that is 1. HV എന്ന് ഞാൻ വിളിക്കുകയാണ്. Suppose we call it as HV. Then HV is equal to vertical height. It's equal to T square G by 8. It's equal to 4 squared into 10 by 8. 16 into 10 by 8. 20 meter. Now this is 20 meter. This is 20 meter. Okay, yes. Now we have to find this one. This is small h, if I say. Now here in the vertical direction is a dropped body. Because I is 1, vertical velocity is 0. Now it is returning. There was a dropped body along the vertical direction. And it traveled, how much time it traveled from here to here? To reach here it is 3 seconds. And to reach here is 3 seconds. And therefore for this journey, time is equal to 1 second. Which is a dropped body in 1 second. What the point I think? To reach here 2 seconds. To reach here 3 seconds. And therefore to travel this vertical height as a dropped body, it took 1 second. For a dropped body in 1 second, what is the distance traveled? So h, small h is given by a dropped body in 1 second of gt square. Of gt square is equal to half into 10 into what? 5 meter. So this is 5 meter. Now the question is, what is the height of the building? We already wrote down the height of the building h is equal to hv minus h. Is equal to 20 minus 5, 15 meter. So that is our answer. 15 meter. Okay, we can go to our next question. A paratrooper jump from an aeroplane and open a parachute after 2 seconds of free fall and start decelerating with a 3 meter per second square at a 10 meter height from the ground while descending with the help of parachute. The speed of the paratrooper is 5 meters per second. The initial height of the aeroplane. Now see, we did earlier. See what is the situation. Suppose this is the plane from which the paratrooper drops. He is a freely falling body, free fall. for how much time? Parachute jump from the aeroplane and jump and open the parachute after 2 seconds. 2 second free fall. So that is the free fall. Free fall for 2 seconds. What is the distance traveled? Half into 10 into 2 square. 20 meters. Now if went down 20 meter free fall, half GT square, dropped and free fall. And what is the velocity? And here on reaching, he opened the chute like this. And what is the velocity of that man the moment when you switch on the parachute? Equal to GT free fall, V is equal to U plus AT, GT. Here the velocity at this position is equal to GT is equal to 10 into 2, 20 meters per second. From there, what he is doing, he is going with a deceleration of A is equal to minus 3 meters per second square. And at 10 meter height from the ground, suppose this is the ground, and from this is 10 meter, and not reaching here, from here to here, on reaching here, when the person reaches here, it is said that when he is 10 meter from the ground, what is said in the problem? 10 meter height from the while descending with the help of a parachute, speed of the parachute is 5. So here is V is equal to 5 meters per second. Initial height of the airplane, that is us. Now, for this journey, you know, you are given U, you are given A, we are given V, and this distance we say yes. This distance if you say yes, then S is equal to what? Now V square is equal to U square. V square is equal to U square plus 2AS. Write down here V square is equal to 5 square is equal to U square 20 minus 2 into 3 into S. From this S is equal to 20 square minus 5 square by 2 into 3. That on calculation is 62.5 meter. This on calculation 62.5 meter. Mathematical value you can do. That is equal to 25 into 15 by 2 into 3. That is the value. That is equal to 62.5. Now the question is, what is the total? Now this distance is 20 meter, this is 10 meter, and this you already calculated 62.5. Therefore, total distance is equal to 20 plus 62.5 plus 10. It's equal to 92.5 meter distance. Next one. An object is projected with a kinetic energy K from a point A at an angle 60 degree with the horizontal. The ratio of the difference in kinetic energy, the point B and C. Difference in kinetic energy between the points B and C to that at the point A. We have to find the difference in kinetic energy between these 2 points. And they divide with the kinetic energy at a initial kinetic energy. That's okay. You know, the difference in kinetic energy between these 2 points. Difference in kinetic energy, the body projected at an angle 60 degree. And therefore, Here the kinetic energy is K at the point at A. Kinetic energy is equal to K. At B, kinetic energy is equal to here is equal to mu square is equal to mu cos theta whole square. Therefore, kinetic energy is equal to K cos squared 60. That is the kinetic energy at this point B. Is equal to K by cos 60, 1 by 2 square, 1 by 4. And reaching here, again it is equal to K. At C, is equal to K. So what is the difference in kinetic energy? Difference between kinetic energy between B and C, C and B, equal to K minus K by 4. That the difference in kinetic energy at these 2 points is equal to 3 by 4K. Now what is asked? This difference by initial kinetic energy. For our answer is 3 by 4K by K equal to 3 by 4. 3 is to 4. 3 is 4. So the answer is here. Okay. We shall go to our next question. A projectile is thrown upward at an angle 60 degrees with the horizontal. The speed of the projectile is 20 meters per second when its direction of motion is 45 degrees with the horizontal. The initial speed of the projectile is, that is what is asked. Now we can draw, from here we are projecting the body at an angle 60 degrees. Now this is 60 degrees. And initial velocity is given to 20 meters per second. Now the path will be like this and reach the maximum here. But there is a location where given that suppose when it reaches here, make an angle 45 degrees with the horizontal. Velocity is going to be dash. This is 45 degrees. At that location, here it was 60 with the horizontal, here is equal to 45. But what the speed become a dash with the horizontal. Now question is, sorry, I'm so sorry. Initial speed is, see, this is, I'm wrong. It is, this is not. Now this is V. And here V dash is equal to the problem, I'm sorry. The speed of the projectile is 20 meters per second when its direction of motion make 45 degrees. So here it is 20 meters per second. Then what is B? They are asking. You know that for a projectile, anywhere during its flight, horizontal projection from the ground, throughout the flight, anywhere, horizontal component of velocity is the same. Therefore, we can write P cos 60 is equal to P dash cos 45. And P is equal to P dash is 20. Cos 45 1 by root 2 by cos 60. Cos 60 is equal to 1 by 2. Is equal to 20 root 2 meter per second. So the answer is okay. Next question. A river about 200 meters is flowing from west to east with the speed 18 kilometers per hour. Kilometer per hour means 5 by 8, 5 meters per second. 5 meters per second. Body move with the speed of 36 means 10 meters per second. In still water. It made to travel one round trip bank to bank of the river. Minimum time taken by the boat for this journey and also the displacement along the river bank. minimum. Therefore, he must opt least time mode for this training. Least time mode. Least time mode means he must always swim perpendicular to the flow. But due to the velocity of the river, he drift. And hence, the path, actual path seen by you when he swim from here A, and this is the direction of flow of the river. He swim perpendicular to the flow, but the path will be like this. And we just see. This is the path taken by him. He is always swimming perpendicular to the flow, but due to the river velocity, he drift and reaches here. Now the question, two questions are there. What is the time? In least time mode, if d is the distance, d is the width of the river, and v is the velocity of the man, and the time to cross the river is going to be d by v, and to return back again d by v, and therefore total swimming time in this, least time taken by him to complete this task is equal to 2 into d by v, is equal to 2 into least time is equal to 2t, equal to 2 into d, width of the river is given to you. A river 200 meters. By velocity of the swimmer. What is speed? Boat with a speed of 10 meters per second, right? Cancel out 40 seconds. Time taken is 40. Now there are three options, 40. Next, what is the drift, total drift? Drift is given by, he is drifted in the direction of the river by river velocity for how much time? 40 seconds. And the drift, suppose this is A, B, C. So AC is equal to velocity of the river 5 meters per second. The time is equal to 40 seconds, 200 meters. And therefore, the answer is this one. Just. Now, this finishes our first two chapters, units and dimension and kinematics. We meet again like this similar video from the coming chapters. Thank you. If there is no applied forces there, what is going to happen is that if we keep the body there, remain equilibrium there, because the starting friction will adjust and assume 25 Newton and keep the body at rest. Potential energy versus distance is given by the graph. Rank various region as per the magnitude of force. At magnitude they are simply asking. Now we are given potential versus distance graph. You know F is equal to minus dV by dx or dr. Modulus of force in slope, simply modulus of slope of graph. We have to see where slope is more and arrange them. Now to come down with the uniform velocity on rough surface, what is the data that is you have to give? That is the data that you have to give is equal to downward force is equal to frictional force. Downward force is equal to mg sin theta is equal to mu mg cos theta. This will cancel out. Sin theta is equal to mu cos. Welcome, my friends. Today we are going to do questions from chapters laws of motion and work power energy of last JEE Main session. You can straight away start doing. The very first question is there on the board. Now come to our very first question. And the question is from chapter laws of motion. Go through the question. A small ball of mass m slide down on the top of a frictionless inclined plane, while the inclined plane is moving towards left with an acceleration is 0. The angle between the inclined plane and the ground is theta, and its base length is L. Assuming that initially the small block is at the top of the inclined plane, the time it will take to reach the lowest point of the inclined plane. Now see, suppose the block is not in motion, if it is at rest, the distance the M has to go over the inclined plane is this inclined length. That you can see, this is the length. Now this is the length. And we are given this is L and this is the theta. And therefore this length is equal to, this length it has to cover is equal to, from trigonometry, L by cos theta. Because cos theta is equal to L by this distance. Therefore, that distance is L by cos theta. So the distance it has to cover or the inclined plane is equal to L by cos theta. Next thing, if there is no acceleration for the frame, the acceleration with which that block come down along the inclined plane and there is no friction is given by G sin theta. Come down with an acceleration G sin theta. Now, in our problem, this block is subjected to an acceleration, horizontal acceleration. Then there will be pseudo acceleration and force on this block towards the right. And that pseudo force along this direction is equal to M A0. Resolving that pseudo force into two components, one up the inclined plane, and that is equal to, if this is theta, this is theta, this is Ma0, the pseudo force, because the block is moving along this direction, accelerating in this direction. So pseudo force is Ma0. The acceleration up component is equal to Ma0 cos theta. And the acceleration up is given by A0 cos theta, up. But already gravity acceleration is G sin theta down. And the effective acceleration or a relative acceleration, effective acceleration of the block of this mass on the block when the block accelerates toward the left is given by G sin theta minus Ma0 cos theta by M. That is equal to A0 cos theta. This is the effective acceleration. Now the distance the block has to cover on the inclined plane, we already wrote down, displacement is given by L by cos theta. Start from rest, U is equal to 0. So it's a one-dimensional problem now. We are given, yes, you are given here, and we are given A. And what is that is what is asked. The time it will take, we have to find the value of T. What is T? To find the T, you know, S is equal to Ut plus half AT square. From this, S is equal to Ut plus half AT square. This is the formula we are going to use. Here S is L by cos theta. 0 plus half into acceleration is G sin theta minus A0 cos theta into T square. From this, T square is equal to 2L by cos theta into E sin theta minus A0 cos theta. Or T is equal to root of 2L by. Now G cos theta sin theta. We multiply by 2 and divide by 2, and therefore here I am writing a 2. Then this time equal to 2 cos theta into g sin theta means g into 2 cos theta sin theta is sin 2 theta. But this term become g sin 2 theta. We multiply and divide, and dividing term is then the numerator. This term is equal to 2 a0 cos square theta minus 2, because we multiplied with the 2, a0 cos squared theta is equal to root of 4l by g sin 2 theta minus the cos square theta. Here you can see that instead of that is equal to 1 plus cos 2 theta there. Therefore, this time a0 2 cos square theta is replaced by trigonometric identity by 1 per cos 2 theta. So it's equal to a0 into 1 plus cos 2 theta. So this is the time equation. It's simply one-dimensional problem. But we have to calculate the effective acceleration on this block when the frame is accelerating to the left. Only thing we have to remember is this one. And hence the option is equal to 4. Okay. We can go to the next question. A particle of mass m fall from rest through a resistive medium having a resistive force F is equal to minus kV, where V is the velocity of the particle and K is a constant. Which of the following graph represent the velocity V versus time t? Now, particle mass m fall from rest through a resistive medium. Now, since it is moving through a resistive medium, it is subject to a retarding force along with the gravity force downward, resistive force up. The net force is equal to gravity force minus resistive force. And net force is equal to ma. And by Newton's second law for this body, here it is mg, and here the resistive force F. And net force is the difference between them because it's moving down. And net force is given by ma, m into dv by dt. That is our F. Net force is given by mg minus viscous force. Viscous force they gave you is equal to minus kx. Minus k, minus k. Now, rearrange this equation. This is the basic equation. Now, rearrange this equation. This can be written as V by dV by mg minus kV 1 by m into dt. And we must get what is the question. We have to find the expression for V. The expression for V from this equation can be obtained only by mathematical operation integration. So we have to do integrate. Integrating integral 0 to V dV by mg minus kV is equal to integral 1 by m dt 0 to t. Now this integration on substitution, integration by substitution, we will get this value is equal to minus 1 by k log mg minus kV by mg is equal to t by m. From this, take the exponential and rearrange. We get velocity equation as V is equal to. Take the exponential and rearrange. Directly we get the value of V. V equal to mg by k 1 minus e raised to minus k by m into 2. This is the solution of this equation. Primarily from the part of physics, we have to get this equation. The rest part is to get the value of V out of this from this equation, for which we seek the help of the mathematics. That's okay. Little bit tedious because we have to substitute here and integrate. You get the answer like this. If you go into this equation, this is definitely an exponentially charging equation. Exponentially charging equation, and exponentially increase and attain as maximum. And C, which is the corresponding equation. This is decay, this is the charging equation. And therefore, definitely the answer is equal to. We can say that exponentially charging the expression is this part. Now, this mathematical activity I did, this part I avoided. If you want, you can go and get the answer like this. This is the mathematical part. Little bit vividly, it is marked there in the video. Now you get the answer. That's okay. So, okay. Next one. A block of mass m 5 kg is moving on an inclined plane, which make an angle 30 degrees with the horizontal. Frictional coefficient between the block and the inclined plane surface is √3/2. The force to be applied on the block so that the block move down without acceleration is. Now, see, this is the inclined plane and our block of 5 kg. The block 5 kg. Moving on inclined plane, make an angle 30 degrees with the horizontal. Here there is a friction is there. Here there is friction on the inclined plane, and the mu is given √3/2. You can see the angular repose of this inclined plane is equal to √3/2, and definitely greater than 30. Definitely greater than 30, and therefore, if we keep this mass here, it won't slide down because the limited friction is more than its gravity component. That is why. Therefore, it is there. And to move the body down with a steady velocity, excess force must be given to this block downward. And we have to calculate that excess force to be applied. Now, what is the gravity component that is acting on here? The gravity component acting on this here is given by mg sin theta. Gravity component mg sin theta equal to 5 into 10 into sin 31/2 is equal to 25 Newton. What is the maximum frictional force that will be there on the body? Here, this is gravity component Fg. And this is the frictional force F. F upward is given by U mg cos theta. It's equal to mu is given to √3/2 m5 into 10 to cos 30 √3/2. This value on calculation is equal to 37.5 Newton. If there is no applied forces there, what is going to happen is that if we keep the body there, remain equilibrium there because the static friction will adjust and assume 25 Newton and keep the body at rest. But in our problem, we have to move the body down. Therefore, what is the additional force to be applied along this one? That is the difference between additional force to be applied additional force to be applied downward or downward along the inclined plane. It's gone by 37.5 minus 25, 12.5 Newton. 12.5 Newton, and the option is equal to. Okay. Next, a flexible chain of mass m hang between two fixed points at the same level. The inclination of the chain with the horizontal at the 2 points of support is steady. Consider the equilibrium of each half of the chain. Tension of the chain at the lowest point is. Now suppose this is the chain, marked like this. Now here it is supported. So that this angle is equal to 30. And mass of the block is equal to mg. Effectively, we can say that there is acting particular down through its center, that's equal to mg. Since the rope is not an ideal rope, it has got mass, and therefore tension need not be uniform. Tension need not be uniform. So tension is different at different part of the string. Remember that. Tension is different at a different part of the string. But the system is equilibrium. Our vertical equilibrium and horizontal equilibrium is maintained at all points and over the entire system. Now at this point, you look. Suppose at that point, the tension there is equal to T. Now the reaction force here is T. Can be resolved. Let it this one. This is T cos 30. This is T sin 30. Similarly here, T cos 30, T sin 30. Now at this point, the horizontal component balance. Vertical component balance, entire vertical component support the weight of the body. Therefore, for vertical equilibrium, you can write 2t sin theta equal to mg. 2t sin theta is equal to mg. So 2t sin 30, 1 by 2, mg. And therefore T is equal to mg. At this point, the tension is equal to mg. Here also tension is mg. But I told you at a different part, tension is different. And at this point, if you come, the lowest point, question is tension at the lowest point. The tension at the lowest point, if you come, say, is T dash. Then T dash, here you can say that this is T dash and this is T dash. T dash, that is the, but horizontal direction, all points are in equilibrium. So at any point, if you look, the horizontal component must be the same. Therefore, you can say the horizontal component, because all the points are in equilibrium, horizontal component here and here are the same. And therefore, you can write T dash is equal to T cos 30. T already you got mg. Therefore, T dash is equal to mg cos 30 root 3 by 2. Therefore, T dash is equal to root 3 by 2 mg. Is our answer? Question number 4, root 3 by 2 mg. Remember, tension is not same. In different body it is different, but horizontal direction, tension, symmetric point, the tension along the horizontal point direction will be the same because it is in horizontal equilibrium. Okay. Now come to next question. In a given figure, the block A, B, C weigh 4 6 and 8 kilogram respectively. The coefficient of sliding friction between any two surfaces is 0.5, and friction is that everywhere, and it is 0.5. The force required to slide the block C with a constant speed is equal to. Now we see here there is friction, here there is friction, here there is friction. The interfaces there are friction. And since it is connected by a string, tension is the same all along that string. Let it be T. Then if we draw the free body diagram of each block, if you take the C, marking C, this is C. Now it is pulled by the tension here, tension T. This is T, the tension. Well, we are marking the free body diagram of C. Now when it is pulled here with the force F, with tendency to move along this direction. And therefore, here there is a friction. Here there is friction. Try to prevent its motion. And that is called mu mg. Mu, what is the total mass there? It's equal to 4. This is 4 kilogram. And this one is 6. And the last one is 8. And here the mg, normal action is equal to weight of all of them. That is equal to 6 plus 4 plus 8, 18 mg. Mu mg. This is the friction force here applied by this surface on this block. Again, when it moves, the upper block try to prevent by generating force along this direction. Here also the frictional force. Again, mu mg. Here m is equal to a plus b. A plus b is equal by 10. And m into g. Now this is the free body diagram of block C. Now what about the free body diagram of B? On B, it is connected by means of string. So here there is tension. And what is the duty of the tension? The tension is when the block B move, here there is a frictional force here. And that is equal to mu mg, that is equal to 10 u into 10 m into g. When it move, the block A over this, try to prevent generating a force here, mu m is equal to 4 m into g. Now, since there is no acceleration from the free body diagram of B, what is the inference you got? Right hand side and left hand force must be same. Therefore, here T is equal to 10 plus 4. 10 plus 4, 14 mg. 14 m into g. That is the tension, 14 m into g. Now here, since there is no acceleration here, for the from free body diagram of C, since there is no acceleration, what is the thing you can write? M is equal to right hand side forces. That is equal to mu 10 mg plus mu 18 mg plus T. Now substituting T there is equal to what is the mass of the body? Oh, there is no need of writing M because take M is equal to 1. Take M is equal to 1. Of 8, 6, 4. Yes, M is equal to 1. Now mu into on addition 28 mg plus T 14. Mu is given by 2 is half. So this on mu into 42 mg. Mu is equal to 0.5 of 42 is equal to 210. So F is equal to 210. So the answer is equal to 210 newton. That is our answer. We wrote down, we drew the free body diagram of these two bodies and solve and get the answer. There is no acceleration anywhere. Yes, next question. Assuming our force constant 15 Newton is cut into two pieces. The ratio of their length 1:3. Then the force constant a smaller piece. Now suppose this is our spring. It is cut 1:3 and therefore for convenience I am saying 4L. 4L. And the spring constant is given 15 per meter. Single spring. Now we are going to cut that into 1:3. So we cut. So that this is L and this is 3L. So 1:3. So this is the smaller piece. Whose spring constant is K1 and length is L. This is the larger piece of length 3L, spring constant K2. And what is this? The force constant of this smaller piece. You know for a spring, K into L is a constant. Therefore, you can write K1 into L is equal to K into L is a constant. 4L into 15. 4L into is force constant 15. It's out. So K1 is equal to 60. Now the answer is equal to this. Next question. Body of mass 14 kilogram initially at rest explode and breaks into 3 fragments of masses in the ratio 2 to 3. The two pieces of equal mass fly off perpendicular to each other with the speed 18. The velocity of the heavier fragment. Now, the ratio 14 kilogram total mass divided into 2 to 3 means 4, 4, 6. 4, 4, 8 plus 6, 14. Now, this is the block of 14 kilogram. Now, fragmented like this. After fragmented like this. So that this is of 4, 4 and this is 6. Next what is saying? The two pieces of equal mass 4, 4 fly in perpendicular. So this one went with the momentum P1. Then this one is also went out with the same momentum P1. So mass is the same. And same speed 18. So momentum of this and this are and angle between them is 90. The velocity of the heavier fragment, that is what is asked, this one. P2. P2. Now you know, since they are perpendicular, and linear momentum is conserved, the resultant of these two must be equal and opposite to the momentum P2 or the larger piece. Okay? The resultant of P1 and P1 or P1 and P2 if we say, here P and P because they are equal mass and equal velocity, we wrote down as P1. And angle is 90 degree. And what is their resultant? Two identical vectors at an angle 90 degree, root 2P. But their resultant is root 2P1. Equal and opposite to the momentum of the next piece, that is P2. The modulus value of these two must be same. There is root 2 into 4 into 18 is equal to P2. P2 mass of this one is 6 into A dash. So this one from this P dash is equal to 3. 12 root 2. And the answer is 12 root 2. And what we applied is simply the momentum conservation law. Okay? A block is sliding down an inclined plane of slope theta and an instant t is equal to 0. This block is given an upward momentum so that it start moving up on the inclined plane with a velocity u. The distance traveled by the block before its velocity becomes 0. Now, a block is sliding down inclined plane, slope theta. It is sliding down, but that data not fully given on the question. Strictly speaking, this body is already sliding down with a uniform velocity, say. It has got some velocity downward direction. And at an instant, doing its downward journey, that means it has got some velocity and that must be steady, not accelerating. Then only the question we can do, or we have to assume so. When it come down with a steady velocity, given a upward momentum, so that it gained velocity in the upward, and due to this initial velocity, it went up to a certain height. And what is the distance traveled? That is what is asked. Initial data we have to assume, or that is the truth. It is coming down with a uniform velocity. It is coming down with a uniform velocity on a frictional surface. Now, to come down with the uniform velocity, on rough surface, what is the data that is you have to give? That is, the data that you have to give is equal to downward force is equal to frictional force. Downward force is equal to mg sin theta is equal to mu mg cos theta. So this will cancel out. Sin theta is equal to mu cos theta. Question number 1. This data, it is better, they say, a body come down with uniform velocity on a rough inclined plane. Subjective. That is not given, but that is the problem. And therefore, sin theta is equal to mu cos theta. The first data. Next thing, what they say, when it is projected with the velocity u, when it start moving up, then what is the effective acceleration or deceleration subjected? Of the second part, when it is projected up, because you have applied a momentum, it is said. So it has got, and it move with the initial velocity u. About u is equal to u. Then it is moving up. Then what is the effective acceleration? Effective acceleration is equal to g sin theta minus mu g cos theta. For upward journey, initial velocity is equal to u, and the acceleration, when it move up, this is equal to plus. Okay, gravity is downward, friction is downward, and therefore g sin theta plus mu g cos theta. That is the acceleration. Now it's one dimension motion. It finally stops. What is the distance traveled? Stopping distance. You know V square is equal to, our formula, V square is equal to U square is 2s. U is equal to 0. From this, S is equal to V square by 2V. Is equal to V square U. Sorry. Then what about here? V is equal to 0. U square is better. So U square by 2E. This is the answer. U square by 2E. U square by 2 into A is equal to g sin theta plus mu g cos theta. But from equation number 1, mu cos theta is equal to sin theta. Mu cos theta is equal to sin theta. And therefore, mu cos theta is equal to sin theta. So this is again equal to g sin theta plus mu cos theta is equal to sin theta. Mu cos theta is equal to sin theta. So g sin theta, and therefore is equal to g sin theta plus g sin theta is equal to 2g sin theta. That is this acceleration part. Therefore, u square by 2 into 2g sin theta is equal to u squared by 4g sin theta. So option is equal to 3. Remember the first data we have to accept. Coming down with a velocity, uniform velocity. Why? Because this condition. Second part is a body projected up and rough inclined plane, how long it goes. That's okay. A large drum having radius r is spinning around its axis with angular velocity omega, shown in figure. The minimum value of omega so that the body of mass m remains stuck to the inner wall of the drum, making the coefficient of friction between the drum surface and mass m as mu. Now, this is the drum which is spinning about this axis, angular velocity omega. Now, my body of mass m like this. Suppose the person mass m is simply stuck here. And what is the speed? When it rotates with angular speed, the pseudo force or the centrifugal force acting on the body is equal to mr omega square for the action. And then the friction upward is equal to mu n, mu mr omega square. That support the weight of the body mg to be there. To be there, we can see the upward force is balanced by the gravity force. That's okay. Upward force due to friction is equal to mu mr omega square is equal to mg. M will cancel out, and we have to find what mu or omega. Omega is equal to g by mu r root. And the option is g by mu r. Option is 2. Next one. 4 kilogram mass moves under the influence of the force 40 cube I minus 3 tg Newton. That is in time second. If mass start from origin at t is equal to 0, velocity and position after t second. Now we are given mass and force acting. Once you can get the momentum function. Sorry. We can get the acceleration function. Now acceleration is given by f by m. Acceleration vector. That is given by f by m if you write 4 by 4. That is equal to 4 t cube by 4 means t cube I minus 3 by 4 tj meter per second. This is the acceleration vector. Now what is asked? Now once you got the acceleration vector, we can get the velocity vector and you can get the displacement vector. But they are asking, if the body starts from initial condition when t is equal to 0, u is equal to 0, that's okay. The velocity and position after 2 seconds. Now, what is the velocity function? Velocity is given by equal to dv by dt. Therefore, dv is equal to a dt. V equal to integral a dt is equal to integral 0 to t. T cube I minus 3 by 4 t j dt. The two components you can have. The x component is given by integral 0 to t d cube dt minus 3 by 4 integral t dt 0 to t. This is the velocity. Once you got the velocity function, displacement is given by integral v dt. Same activity you have to do again. And you can get the displacement value. And substitute the value of t in velocity as well as position. You can get the velocity and position vector. Now, that activity here, the acceleration is given by velocity after that integration. Velocity is given by t raised to 4i 3 by 4 t square. Now the value put t is equal to 2, you get the velocity at that from that function. Next, position, integral v dt. So velocity function is integrated and you put the t is equal to 0 like this. You get the position vector. That's okay. And this is the answer. What is the velocity here? Here the velocity is say v. The total energy here and total energy here must be same by energy conservation. Here and here the total energy must be same. Here the total energy pure kinetic of mv square. Here there is elastic collision and between identical body. Then what happened? They will exchange their velocity. They will exchange their velocity. That means on hitting, this will carry the velocity of A and move with the velocity of A and reaches here and takes circular motion. We have heat equation is mc delta theta. M is equal to 40. See the specific capacity. Specific capacity is given to you as 81 calorie per kilogram. 81 into calorie per kilogram. Calorie. Joule per kilogram we are required into 4.2. This is the question from work power energy. In the case of a vertical circular motion of a particle by a thread of length r, if the tension in the thread is 0 at the end angle 30 as shown in figure, the velocity at the bottommost point A of the circular path we have to get. What is the velocity here? So that on reaching here, the tension is 0. Tension 0 means the mv squared by r is balanced by the component of the gravity towards the center. That's okay. If you draw the figure again, from here we project so that body reaches here. This angle is 30. Here, if v dash is the velocity or v dash is the velocity here, then the outward force is called m r or mv squared. mv squared by r. That is, suppose this is 30, this is 60. And this is mg. So this component is called mg cos 60. Here the body is said that not apply any action at this point because the tension on the string is 0. Tension on the string 0 means tension is caused by mv squared by r minus mg cos 60. That is the tension. But the tension is 0. But tension 0 here means m v squared by r at that point, v dash, v1 v dash. M v dash squared by r is equal to mg cos 60. From this, v dash square is equal to m cancel out rg into cos 60 is equal to rg by 2. Or v dash is equal to root rg by 2. At this point, you got the velocity of the particle. So that the tension here is 0 or it is not applying any normal action on that. If it is of a sphere or something. Or there is no tension on the string, condition is this one. Next. If this is, how much is the radius? R. Then what about this side? This is equal to 30. This is equal to r sine 30. R sine 30 is equal to r by 2. So this is r by 2, this height. This is r. Now what we are going to do, what is the question is, what is the velocity here now? What is the velocity here? Here the velocity say is v. The total energy here and total energy here must be same by energy conservation. Here and here the total energy must be same. Here the total energy pure kinetic half mv square. At this point, put that point at A, total energy is equal to half mv square. Is equal to total energy at what is the point? We didn't give a name. Here the point C. At C, total energy at C. Total energy at C mean half mv dash square, where v dash is velocity at that point, plus the gain in potential energy mgh. H is equal to r plus r by 2. mg r plus r by 2. M cancel out. So from this v square is equal to v dash square to cancel out rg by 2 plus 2g multiplied by 2 r plus r by 3 by 2 r. Is equal to 3 rg plus rg by 2 mean 7 by 2 rg. Therefore, v is equal to root of 7 by 2 rg. 7 by 2 rg, there. Question. Option is 1. So we apply the energy conservation and get the answer. Next one. A bead P is sliding on a frictionless semicircular string ACB, and it is at the point S here. It is at here. At t is equal to 0, and at instant horizontal component of velocity is p. That means along this. Here is horizontal velocity is v. Here horizontal velocity is v. It has got effective velocity more than v along the tangent. But here the horizontal velocity is v, and starting from here when t is equal to 0. Another bead Q of the same mass, the its instant horizontal component of velocity is v. Not the total velocity, horizontal component is v at this point. That means as it moves here, the horizontal velocity increases because of the gravity effect. And here it has got the maximum velocity here, much more than v. Again decrease, and on reaching here, again the velocity will be, thereafter it may decrease. It's okay, horizontal velocity. That means throughout the journey from here to here, its average speed is much more than v. Agree with me? Here is v, increase, and here is much more than v. On reaching here, it is again v. So here the velocity, average velocity much more than v, average horizontal velocity. Whereas hereafter this may be less than v. But overall, if you take the velocity, average horizontal velocity is more than v through this journey. Throughout this journey, the average horizontal velocity more than v. Argument is clear. Next part, it is what it says. Another bead Q of same mass P ejected from A from here along this direction with the same velocity v. Friction between them, etc. neglected. Let Tp for this particle. Tp, first particle, and Tq for this particle. Time taken by the bead P to Q, P and Q to reach that point B. From here to here, time taken is equal to Tp. From here to here, by this particle is Tq, which is greater or which is less. This is what is asked. Then the relation between Tp and Tq. Here, the average speed is much larger than V. Here throughout is V. And therefore, time taken to cover this distance with a horizontal speed or average speed is larger than V. The time taken is less. Therefore, Tp will be less than Tq. Tp less than Tq. That's okay. Argument's sake, we can get it. Because here the horizontal speed is much more than this one. Major part of journey, horizontal speed is more for this particle, and therefore time will be less. Therefore, Tp less than Tq. Okay. A small bob A of mass m is attached to a massless rigid rod of length 1 meter. Massless. We are not bothering about its energy factors. Then pivoted at the point P and kept at the angle 60 degrees here. With the vertical as shown in figure. At a distance of 1 meter below the point P, a nickel bob B is kept at rest on a smooth horizontal surface, this one. That the extend to a circular track. So if it will take a circular path on this track. Radius R as shown in figure. If the bob B just manage to complete the circular path, it is just complete the vertical path and fall. So okay. Circular path of radius R up to the point Q. That we need to take up. It is just negotiate vertical circle. That's okay. On reaching here, it will move along the tangent. That's okay. Because the frame is not there. But the problem is that it is taking vertical circular motion. And minimum speed is required at the bottom is attained. That's okay. Or just to complete vertical circular motion. What the minimum speed required at the bottom? Minimum speed required at the bottom. Minimum speed required at the top. Root of Rg. Here, what the minimum speed required at the bottom is equal to root of minimum speed required here, so that it will take up negotiate the vertical circular motion. Root of phi Rg. Here is equal to root of Rg. Here there is root of phi Rg. Minimum speed required, so that it take up vertical circular motion. Then find the radius. Now what we are going to do? Here there is elastic collision and between identical body. Then what happened? They will exchange their velocity. They will exchange their velocity. That means on hitting, this will carry the velocity of A and move with the velocity of A and reaches here and takes circular motion. But instead of saying so, what I am going to say, well, that is what is happening. Now, due to this purposely elastic collision, whatever energy lost by this body when it falls from here to here, when it reaches from here to here, it has potential energy. That potential energy is gained by B and reaches here in the form of whatever potential energy lost here is the kinetic energy of this body at this bottom. That due to that kinetic energy, it has got velocity, how much root of phi r, so that it take up vertical circular motion. Or the total energy of this B on reaching here and total energy of the body here are the same. And here it is doing just vertical circular motion, means speed at the top is equal to critical speed root of Rg. But at the top, speed is equal to root of Rg. The bottom, it is root of phi Rg. And here, if you write down the total energy, our total energy at here I am saying X and here it is Y, top. Our total energy at X equal to total energy at or the total energy at X of p square. What is the velocity required at the bottom to take up vertical circular motion is root of phi rg. So phi rg per square. Good. Total energy at Y mean potential energy. Potential energy is equal to mg into 2r plus half m p square root of rg. But from where this body has got this half root phi rg whole square kinetic energy. The loss in potential energy of A on hitting on B. But total energy of this body is the energy of this body, loss of potential energy of this body. So this is same as loss in potential energy of A is the gain in kinetic energy of B to B, which is same as the gain in kinetic energy here. Therefore, I am saying loss in potential energy of A is equal to total energy here. So I'm doing is equal to 2mgr plus half mg. Now, what is the loss of potential energy of A? Here, this is 60. This is 1 meter, and this is 1 meter, and this is equal to 1 cos 60 or half meter. Therefore, this is half meter. The loss in potential energy is equal to mg into height. Loss in potential energy of A is the gain in kinetic energy of B equal to mg h. Is equal to mg into h is equal to half. Is equal to 5 by 2 mg. From this mg will cancel out. R is equal to 1 by 2. Remember, I am not calculating the velocity, but the velocity gained by this. Otherwise, we can do so. What is the velocity gained by B? Loss in potential energy is gained in kinetic energy of this one. And that velocity on reaching here must satisfy root of phi rg. And do the same thing and get. Yes, straight away we equated the energy and got the answer in a simple manner. So, okay. So answer is equal to 4 or 3. Next question. Two blocks with 100 gram and 200 gram are attached to ends of a spring A and B shown in figure. Energy stored in A is E and energy stored in B when spring constant K and KB of A and B respectively satisfy the relation. So we are given here 4 Ka is equal to 3 Kb. Now, for the energy stored in A, energy stored in A is E. So what is E? Energy of A. E equal to, in terms of load and extent, spring constant F square by 2K. Okay. E is equal to F square by 2K. What is the load? 0.1 whole squared by 2K. That is our equation number E. Now for B, E dash that we have to find. E dash is equal to F square, again formula is the same, 0.2 whole squared by 2 kb. Now 2 by 1 gives, dividing E dash by E equal to 0.2 whole squared by 2 kb into 2 Ka by 0.1 whole squared. It's equal to Ka by Kb into 2 by 1, 2 square 4. Ka by Kb from here is equal to 3 by 4. It's equal to 3 by 4 into 4. So E dash is equal to 3E. E dash is equal to 3E. So okay. A perfectly inelastic collision, two spheres made same material with the masses 15 kilogram and 25 kilogram move in opposite direction with the speed of 10 and 30 meter per second respectively, strike each other and stick together. Perfect inelastic collision. The rise in temperature. If all the heat produced during the collision is released by these spheres, retained by these spheres, what is the rise in temperature? Now, what we have to, first of all, we have to find out what is the energy loss in this collision. Energy loss. Now, the two spheres, mass is 15 and the other one is 25. And move in opposite direction with the velocity. This is 10. And the other one is minus 30, opposite direction. And stick together to form a single body of mass 35, 40. And velocity v dash. Now we have to find what is v dash. Linear moment conservation. Because the 10 into 15 plus here minus because of minus 25 into 30 is equal to 40 into v dash. This on calculation. $600 equal to 40 into v dash. From this, v dash is equal to 600 by 40 is equal to 15 meter per second. 15 meter per second. Definitely, I am not bothering about sign in which direction they are moving. Not at all important. 15 meter. Next thing, what we have to find, what is the energy lost? What is that energy loss? Total kinetic energy before half m into 15 square. No, I'm sorry. Mass is equal to 15. 15 into 10 square plus half into 25 into 30 square. This is the total kinetic energy minus kinetic energy after collision of total mass is 40 into v dash square 15 square. This is the energy lost. This energy loss on calculation, the energy difference on calculation is found to be 7,500 joule. Now this heat is accepted by the combined body and rising temperature is there. Energy, and if delta theta is the rising temperature, then what is the heat required for that MC? Delta theta is equal to this much, M 40 kilogram. M heat equation is MC delta theta. M is equal to 40. See the specific capacity. Specific capacity is given to you as 31 calorie per kilogram. 31 into calorie per kilogram. Calorie. Joule per kilogram we are required into 4.2. 31 into 4.2 into rising temperature. The heat required, heat energy required to rise for rise temperature delta theta is given by MC delta theta is equal to energy lost during this collision. From this delta theta is equal to 7,500 by 40 into 31 into 4.2. This is approximately 1.44 degrees centigrade. So option is okay. Next, given below R2 statement, an object move from R1 to R2 undergo conservative force field F. The work done is given by minus integral R1 R2 F dot dr. Minus in a conservative force field minus R1 to R2 F dot dr is the potential energy, not work done. Work done is plus R1 to R2 F dot dr, not minus. So this statement is wrong. That statement is wrong. Second one, because this is potential energy change and not work done. Any object moving from one location to another location can follow infinite number of paths. Therefore, the amount of work done by object changes with the path it follows. In a conservative force field, it is not a path function. It depends only on initial and final, and therefore this statement is also wrong. Both statements are wrong. What is the both statement 1 and 2 are false. So this is the answer. A body of mass 2 kg is moving along x direction with that displacement as a function of time given by the net work done the body during interval 2 seconds to 3. Mass is given 2 kg and we are given the displacement function. Now from displacement function we can get the velocity function. So velocity function is given by dx by dt is equal to 2 alpha t plus beta. This is the velocity. And where alpha is equal to 1 is equal to 2t plus 1. This is the velocity function. Now work done. Work done is given by change in kinetic energy half m v2 square minus half m v1 square. Now what is v1? v1 is t is equal to 2 seconds. v1 is equal to 2 into 2 plus 1 is equal to 5. v2 is equal to 3 seconds. 2 into 3 plus 1 is equal to 7. Therefore, change in kind work done is given by half into mass of the body is given to you 2 kg into 7 squared minus 5 squared. And the value on calculation is found to be 24. So the answer is 1. Okay, next 20. Potential energy versus distance is given by the graph. Rank various region as per the magnitude of force. At magnitude they are simply asking. Now we are given potential versus distance graph. You know F is equal to minus dV by dx or dr. Modulus of force means slope, simply modulus of slope, a graph. We have to see where the slope is more and arrange them. Here you can see that here the slope is maximum, CD. Then AB. Sorry. Here CD first, slope is maximum CD. Then slope is A, not CD, I'm sorry. Slope is maximum with B, here B. BC. Next AB. Then D. Then CD. Now you can see that force BC greater than force AB, greater than force D, greater than force at CD. We simply look at the slope and get the slope. So the answer is modulus of force is the slope. Okay. So this finishes our today's video. Thank you. See you next time. System of particles, rotational dynamics. Definitely all the questions require little bit more mathematical substitution and calculation. All the questions are more time consuming. Before collision, there are two moving particles. 2m about center of mass, 2 centimeter. M, V, R. Equal velocity V. What is the M, V, R? 2m into V into R is from center of mass 2 centimeter. And when the mass descends by 3 meter, so this mass descends by 3 meter and reaches here. That means that body loses potential energy. This body loses potential energy. Next question that is there from system of particles, rotational dynamics. Definitely all the questions require little bit more mathematical substitution and calculation. All the questions are more time consuming, both theory wise as well as calculation wise. You can see that when we go through the problem. Now very first question is there. A flywheel having mass 3 kg and radius 5 is free to rotate about horizontal axis. A string having negligible mass is wound around the wheel, and the loose end of the string is connected to 3 kg mass. The mass is kept at rest initially and released. Kinetic energy of the wheel when the mass descends by 3 meters. Now we can imagine a situation like this. This is the wheel on which string is wound, and you attach a mass here. And mass is 3 kg. Sorry, how much is the mass? 3 kg. And whatever the mass of the wheel, mass is 3 kg. And radius of the wheel is given to you 5 meters. And the rotations, this is a flywheel, a disc. And therefore you can write the momentum inertia of that flywheel. Momentum inertia of the flywheel, I is equal to about the central axis, is equal to disc m squared by 2. This is the formula we are applying. So m is given to you 3 kg into 5 squared by 2. M squared by 2, a disc about central axis. I is known to you. Next, in the problem what they did, this is the 3 kg. Now we are releasing the 3 kg, and therefore it is allowed to fall down again, and due to acceleration velocity increases. And finally a situation they say from rush it releases, and when the mass descends by 3 meters, so this mass descends by 3 meters and reaches here. That means that body loses potential energy. This body loses potential energy because it falls down. And this potential energy used for what? This potential energy is used for kinetic energy by itself, gain some kinetic energy by itself, and also give rotational kinetic energy to the flywheel or the revolving wheel. Now this one gain rotational kinetic energy and this one gain kinetic energy. Rotational kinetic energy of our body is equal to rotational kinetic energy. Kinetic energy of our disk is equal to half I omega square. And kinetic energy of this mass is equal to half m v square. Half m v square. And the rotational kinetic energy is equal to this much. Now, we have to find out what is the energy of both of them. Energy of both of them. Energy of both of them is equal to loss in potential energy. Loss in P is equal to loss in potential energy is equal to gain in kinetic energy of two bodies. Kinetic energy of disk plus mass. Loss in potential energy of the body, we know that mgh 3 into g into, it will fall down through 3 meters into 3. Gain in kinetic energy. The gain in kinetic energy is equal to half mv square. Half mv square. That is the body. And gain in kinetic energy of the disk is equal to half I omega square. Now this can be replaced by that is what is asked, kinetic energy of the wheel when the mass descend by 3 meters. So this factor is asked. For which, what is I? I we already wrote down. I is equal to m r squared by 2. M r squared by 2. But now this can be written as, from this m is equal to half into m going to replace here by means of I. Why I am going to do that? Because we have to get half I omega square, the kinetic energy of the wheel. Therefore, m is replaced by I. So m is equal to 2I by r squared. 2I by r squared into v squared plus half I omega square. It's equal to half 2I by r squared into v replaced by omega. V is equal to r omega. R squared omega squared plus half I omega squared. Now this r square will cancel out. This will cancel out. And therefore altogether half I omega square is equal to I omega square. 3 by 2 I omega square. Half I omega square plus I omega square is equal to 3 by 2 omega square. Is equal to 3 into 10 into 3. From this, half I omega square, our answer. Half I omega square is equal to 3 into 10 into 3 by 3. Into 3. And the value is about, you can see that half I omega square is equal to 30. And therefore 32. And what is the principle applied? Energy conservation. Loss in potential energy is equal to gain in kinetic energy is here. Gain in kinetic energy by two bodies. Okay. Next question. And you can see the calculation from the next page for every question if you want. The position xi plus yj plus zk changes minus r, which one of the following vector will not flip under sign change? The one which won't change because of this sign change. They are asking. You know, angular momentum is equal to r cross p. When this is plus r and this is minus r, a body along this direction now along this direction, so p become negative. R in this direction become in this direction mean r is negative. That means due to this activity, what is going to happen is that when position changes, derivative velocity changes and momentum also changes. This is minus r cross minus p is equal to r cross p. Therefore, L remain the same. Angular momentum remain the same. So, angular momentum won't change. Which one of the volume vector will not? The question is that. So, this is the answer. Okay. Next question. A solid sphere of radius 10 centimeter rotating about an axis which is at a distance 15 centimeter from its center. The radius of gyration about this axis root n centimeter, the value of n is. Now suppose this is a solid sphere. Radius is given to you. R is equal to 10 centimeter. That m is equal to mass. No need of it, but we are writing. Then what if we are asked? We have to find the moment of inertia or radius of gyration about an axis which is at 15 centimeter from the center. This is 10 centimeter and 15 centimeter. This is the axis about which it is rotating. And this is 15 centimeter from the center. Now apply balance theorem. About this passing the center, moment of inertia I about the center is given by solid sphere 2 by 5 m r square. Then about this axis, moment of inertia about this axis, axis theorem. I is equal to moment of inertia about center 2 by 5 m r square plus m s square. Let's get m into 15 square. 15 square. R is equal to 10 square. Known to you. And this 2 by 5 m r is equal to 10. 100 m plus 225. So I is equal to 40 m plus 225 m is equal to 265 m. Question is the radius of gyration. Radius of gyration K is equal to I by root. And therefore you are to write root of 265 m by m is equal to root of 265. So the answer is equal to n is equal to the comparing n is equal to 265. Value is equal to 60. Okay. Okay. Next question. And if you want the calculation, you can see the next page. That's again I'm telling you. For all these questions, because numerical part, a lot to do. That's why. Two circular discs of radius, each 10 centimeter are joined. Their centers by a rod of length 380 centimeter and mass 600 gram as shown in figure. Length of the rod is 30 and mass of each rod is mass of the rod is 600. The mass of each disc is 600. A rod and disc has got same mass. It is a disc, has got same mass, 600 gram, 600 gram. And applied a torque between the two discs is 45 into 10 raised to 5 dyne per centimeter. The angular acceleration of this is about the given axis AB. We are given torque. What is the principle you have to apply? We are given torque. And the torque and the angular acceleration relation is tau is equal to I alpha. Tau is equal to I alpha. Tau is given to you. Alpha is ours. And therefore, you have to find out the value of I. Because alpha is ours. The only thing is, what is the moment of inertia of this arrangement about this Z axis, about the so-called, the given or asked axis, like this. Now, we have to find out the moment of inertia of the entire moment of inertia of the disk about central axis. There are two here also. And they convert about this axis. And transfer them is moment of inertia from this to this axis. Along with the moment of inertia of the rod about central axis. So three quantities we have to add. One, moment of inertia of the rod about the axis. Total I is equal to I of rod plus I of disc 1 about AB plus I of disc 2 about AB. This is the thing that we have to do. And the rod formula about this central axis. Mass is the same for all of them. We can write M L squared, and what is L there? L is equal to 30. M into L squared, 30 squared to 1. Rod about the central axis. Now, that is about central axis. But our axis is not through the center. It is 30 centimeter, and axis is 10 centimeter away from center of the rod. This is center, 30 centimeter. Our axis is this one, and therefore what is the separation? Parallax there we have to apply. M square A is equal to 10 plus M into A square, 10 square. This is the moment of inertia of the rod about the axis AB. Rod about AB is this one, plus moment of inertia of the disc about any diameter, about any central axis M squared by 2, about diameter M squared, about diameter M squared by 4. This is equal to M R squared by 4. Then transfer to by parallax theorem, M into A square. A is equal to here marked as 10 square. This is the rod disc 1. I of disc 2. Disc 1, this is I of disc 2. Disc 2 again is given by plus M R squared by 4, moment of inertia about the diameter, plus 20 M 20 square. And M is given to you. Substitute the value of M. M is equal to 600 gram. R is equal to, we have wrote down, R is equal to radius 10 centimeter. All the data here required is substitute and calculate. Calculate and substitute and calculate and get the answer. This value altogether on calculation, the value is found to be 37,500 unit. This calculation, substitute the value of M and R, get the value. This is the total moment of inertia about in their system about this axis. Now torque is going to, you know that tau is equal to I alpha. Tau is equal to I alpha. Therefore, alpha is equal to tau by I. Tau torque applied in CGS 43 into 10 raised to 5 by 37,500. And this approximately found to be 11. And the answer is equal to 1. Now we can see that much calculation is there. Numerical calculation is okay. And get the answers. Okay. Next question. A uniform cylinder of length L and radius R has got moment of inertia about its central axis is I1. A small concentric cylinder of length L by 2 and radius R by 3 carved from this cylinder has moment of inertia about its axis I2 and I1 by I2. I1, now you can see this is the earlier cylinder. Length L, radius R. Radius is R. Then what is the moment of inertia? And what we did, a small concentric cylinder, so this one, removed out from here about this axis. This much is removed. And we have to calculate its moment of inertia. And the question is, earlier question, when entire system I1, removed out portion moment of inertia is I2. Both are cylinder. One is of radius R and other is of radius R by 3. So is the same. It's okay. In first case, you can say what is the moment of inertia of a cylinder about central axis. I1 is equal to basic formula cylinder about the central axis mean a disk about central axis as m r squared by 2. It's equal to m r squared by 2. What is m? M you can write in terms of length and radius. Pi r squared volume into density. Mass. Volume into density mass into r squared by 2 equal to, or we can say I1 is equal to pi L rho r raised to 4 by 2. That is the moment of inertia in the first entire cylinder. Then moment of inertia of the removed out cylinder radius and mass. And in terms of this relation, we can say what is I2? Pi L is L, rho is rho, pi L rho, because L and rho for the removed out portion are also the same. But what about R? R is R by 3. A small concentric cylinder of length L by 2. I'm sorry. Length L by 2, not L, but L by 2. Not entire time, entire disk is not involved like this. This much is removed. This is equal to pi L by 2. Pi L by 2 into rho, that is the volume, into density. Pi, next what about the radius? Radius is R by 3, so it's called R by 3 by 2. Pi L by 2 rho R by 3 all raised to 4 by 2. A small concentric cylinder of length L by 2, not entire length, L by 2. And R by 3 radius is removed. Moment of inertia from this relation is equal to this much. This one already got here length changes, radius changes. This is our I2. Now, what we have to find? I1 by I2. Pi L squared rho R raised to 4 by pi L rho R raised to 4 divided by 3 raised to 4 into 2. And get the value. 81 into 2 is equal to 162. equal to 3 raised to 4 into 2. 81 into 2 is equal to 162. So the answer is 162. Remember, here not the entire length is not carved out, only L by 2. Remember. Next question. A thin uniform rod X of mass M and length L is pivoted at height L by 3 as shown in figure like this. The rod is allowed to fall from vertical position and lie horizontally. Now it falls like this on the table. And the angular velocity of this rod when it hit the table. Now the basic concept, when it falls, it loses potential energy because center of gravity is at L by 2. Now fall, this is the center of suppose this is the center of gravity or the center of the rod, then this is the distance through which the height falls when it falls down like this. And this value is equal to h. That h is equal to, you can see that, what is the value of h? This is L by 3. This is L by 2. H is equal to L by 2 minus L by 3. Okay. Is equal to 6. 3 minus 2, 1 L by 6. This is the distance through which the body falls. And the loss in P of this is equal to M G H is equal to L by 6. Now that loss in potential energy accepted as gain in rotational kinetic energy of this block, I omega square. And therefore we have to find out what is the value of I. I about this axis of rotation. Axis of rotation is this one. This is the axis of rotation. This is the axis of rotation. And we have to calculate what is the moment of inertia of this rod about the axis of rotation. That is equal to I is equal to I0 about central axis, about this axis. So M L squared by 12 plus MS square. MS square. That is equal to, this is the distance from, it's equal to M L by 6. This is the moment of inertia of this rod about this axis because it is going to rotate not about the axis but about this axis. So add up. By applying parallax theorem, ML squared by 2L plus ML squared M into S square. A square L by 6 is equal to L by 6. Next, if omega is the angular velocity, loss in P equal to gain in rotational kinetic energy. Therefore, mg into L by 6, mgh is equal to rotational kinetic energy half I. I is this thing. That is m squared by 9. This is on calculation. M squared by 9 into omega squared. From this, calculate the value of omega. That on calculation is equal to, this on calculation, omega is equal to root of 3G by L. This on calculation, simply calculate and get the answer equal to omega square. So we have to calculate the value of y, and I value calculation. This calculation yield the value ml square by 9. From this omega can be found. So again, if you want near the calculation, that is there on the boards. Two masses of 400 gram and 350 gram are suspended by ends of a light string passing over a heavy pulley of radius 2 centimeter. On release from rest, The heavier mass is observed to fall 81 centimeter in 9 seconds. The rotational inertia of the pulley is. Now, rather than calculating, suppose there is a massless pulley and there are two masses, M1 and M2. And release, the acceleration is given by M1 minus M2, which are heavier mass minus M1 minus M2 by M1 plus M2 into G. If you take into account the rotation of a disk which has got mass, then acceleration formula useful for you. Acceleration is given by M1 minus M2 G by M1 plus M2 plus I by R square, where I is the moment of inertia of the disk that is rotate in this problem, and R is the radius of the disk. So M1 plus M2 plus R. But this formula is very well useful for us. Now in our problem, we are given M1, M2, we are given, and question is rotation inertia. I has to be calculated. But M1, M2 is given, I is to be calculated. Radius of the disk is given to you. Radius of the disk 2 centimeter. R is given. But next thing, what do we have to do? We have to find the value of A. Now to calculate the value of A, what is the data given there in the problem? The problem is given that starting from rest, U is equal to 0 for this body, fall down through a distance 81 centimeter in 9 seconds. S is equal to 81, time is equal to 9 seconds. Starting from rest, U is equal to 0. What is A? S is equal to UT plus RPT square. Formula applying, yes, 81 is equal to 0 plus half into A into 9 square. 9 square cancel out. You can say A is equal to 2 unit. Once you got the value of A, substitute here. Substitute in equation number 1, 2 is equal to, substituting in 1, 2 is equal to M1 400 minus M2 350 into G 9.8 by M1 400 plus 350 plus I by R square. R is the radius. Radius is 2 centimeter. Radius of the disk is given 2 square. In our equation, there is only one term I can be calculated. So I can be calculated from this equation, and I on calculation around 9.5 into 10 raised to minus 3. So option is equal to 3. So okay. But this formula definitely useful for us. Otherwise, we have to derive it. Next problem. Suppose there is a uniform circular disk. Mass M, kilogram and radius are shown in figure. The shaded region are cut out from the disk. The momentum inertia of the remainder about the axis A, about the same central axis. All the disk is given by the value of x. Now we have to find the momentum inertia of the remainder disk, for which we can see the additive property of the momentum inertia. We can find the momentum inertia about this and transfer that about this using parallax theorem. Similar situation is here, about multiply into 2. That's the total momentum inertia of these two removed part about this axis. And the entire momentum inertia about that axis, m r squared by disk about central axis, m r squared by 2 known to us. Subtract these two values. That is the thing that we have to do. Now, for the momentum inertia, before that, we can suppose the entire mass is equal to capital M, mass per unit area. Mass per unit area, sigma is equal to M by pi, what is the radius, small r, of pi r square. Then what is the area of removed part or mass of removed part? mass of the removed part m1 is equal to, or small m, it is better, small m. Mass of the removed part is equal to small m is equal to area of the removed part pi r by 4 whole squared into areal density m by pi r squared is equal to m by 16. M by pi r squared, square of this one is equal to 16. Radius of the shaded region is cut out. Shaded region has got radius marked as r by 4. Radius as r by 4. So m by 16. This is m, the removed part, m by 16. Now, what is the moment of inertia of the entire disk? I original disk. Mass is m, radius is r, disk upper central axis m r squared. Right. Question number 1. Now, what is the moment of inertia of the removed parts? Two of them are there about the central axis. Now, 2 into by 2, there are two similar parts. Moment of inertia of one disk upper central axis. That is I0. That is equal to m r squared by 2, where m is equal to m by 16. M by 16 r squared r by 4 whole square m r squared by 2. That is about their central axis. Transfer that to central about the axis A by parallel axis theorem. M s square, where m is equal to plus m by 16 into what is A? R, the 3 by 4 r they marked there, r by 4. From here to here the distance 3 by 4 r. S squared means 3 by 4 r whole squared. This is the moment of inertia, one portion, removed portion about this axis. Two similar portions are there here. This is the moment of inertia of removed part. Equation number 2. That on calculation, 19 by 256 m r squared. Now calculate this one. The value is found to be 19 by 256 m r squared. Now question is, I of the remaining part is equal to, this is equation number 1 minus equation number 2. That is m, capital M r squared by 2 minus 19 by 256 capital M r squared. This on calculation found to be 109 by 256. 256 m r squared. 109 m r squared. Now 256 m r squared is therefore comparing x is equal to 109. X is equal to 109. Okay. You can refer the calculations if you need here. Okay. What the basic principle applied is the additive property of moment of inertia. Okay. Next question. Two small balls with masses m and 2m are attached to both ends of a rigid rod of length d and negligible mass. The angular momentum of the system is L about the axis A, passing through its center of mass and perpendicular to rod, then angular velocity of the system. You know angular, before marking, angular momentum and angular velocity related by this called I omega. It is equal to I omega. And therefore angular velocity is equal to L by I. At least L given to you. And therefore, what is our duty? To find out the I of the arrangement. Moment of inertia of the arrangement. And what is the arrangement? Two small balls. This is the M. And other is 2M. Double the mass. The center of mass is nearer to the heavier mass. And the distance separation will be in the ratio. Mass is 1:2. And the distance from center of mass is 2:1. Okay? Distance center of mass 2:1. Here is center of mass. And what is the total length? A rod of length D. And this is D. And that is divided. There is about the 2/3 D. And this is 1/3 D. Point masses. Now our basic principle, we have to find the moment of inertia I about central of this axis. We have to find the moment of inertia. Now here, what is the moment of inertia I? Moment of inertia of this mass. It's a point mass, not a sphere. Two small balls. Radius is not a small point mass. Simply a mass square. So it's equal to M into 2/3 D or square plus moment of inertia of this one 2M into 1/3 D whole square. This one calculation is equal to 2/3 M D square. On adding these two, 2/3 M D square, then omega is equal to L by 2/3 M D square. And this value on calculation is 3/2 L by M D square. So this is the problem. Okay, if you need calculation, that is on next page. Okay. Next. Moment of inertia of a square loop made of 4 uniform cylinders, solid cylinders, not rods, solid cylinders. Each having radius R and length L. R is much less than L. About an axis passing through the midpoint of opposite sides is taken mass of the entire loop as M. Then we can mark like this. This is one side. Similar side is here. Similar side is here. Yes. Now these are all similar. Total mass is M, mean mass of each side is M by 4. And radius of, and this is L, length. And radius is equal to R. Length of each side is L and the radius is R. Mass of each side is M by 4. And we have to find the moment of inertia opposite midpoint of also about this axis. So what about this distance? L by 2. This is L and this is L by 2. Mass of each rod is equal to M by 4. M by 4. Now as you did earlier, here the total moment of inertia, that is what you have to calculate. The total moment of inertia is moment of inertia of these two rods about their central axis. Two rods are there. Then moment of inertia rod about this axis. Transfer that into about this axis. Two of them are there. Therefore, you can write total moment of inertia is equal to 2 into moment of inertia these two rods. These two rods about their central axis. About their central axis. And cylinder about central axis. The moment of inertia, two of them are there. Moment of inertia is going to M. Here M is equal to M by 4. Formula is equal to M L square by 2L plus R squared. It's a solid cylinder. Solid cylinder. M R squared by 4. This is the basic formula. Here M is M by 4 into Length is L itself. L squared by 12 plus M into, I am taking M inside, M by 4 into R squared by 4, R is the radius, is equal to R squared by 4. Two of them are there. M into L squared by 2 plus R squared by 4. Two of them are there. Plus moment of inertia of these two. Moment of inertia of this disk cylinder, I am going to take a disk because the axis is like this. About that is equal to our basic formula, disk about central axis M R squared by 2. Equal to, two of them are, two are there, 2 into M by 4. Formula M R squared by 2, R squared by 2. Plus, transfer that into this, about this axis. Formula is equal to M S square. Is equal to M by 4. A mean L by 2. Two is there because there are two such a distribution masses. Add up all together. That is the moment of inertia, the required answer for the moment of inertia. And the value is about, on calculation, is equal to 3 by 8 M R squared plus 1 by 6 M L squared. And the option is 1 to be 3. Add up all these, you get the answer. Why these two? Because there are two. That's why. Okay. If you need calculation, that is there on the next page and get you. For a mechanical system, many particle total kinetic energy, the sum of kinetic energy of all the particles. Yeah, this is true. This statement is true. Total kinetic energy can be sum of kinetic energy of the center of mass with respect to origin and kinetic energy of all the particles about center of mass. Same statement. That is also true. So 1 and 2 are correct. 1 and 2 are correct means is the option. Both 1 and 2 are correct. Number 1. Two masses. M and 2M are connected by a light string going over a pulley of disk mass 30. It has got mass 30 M. With the radius, pulley is mounted on a vertical plane and is free to rotate about the axis, vertical axis. 2M mass is released from rest and speed when it has descended through height 36 meter is. Now, earlier problem that we did, it has got mass and it has got radius. Now, this is the situation. Mass 2M and M. Released. Descend through 3.6 meter. U is equal to because we are releasing. S is equal to 3.6 meter. B is equal to what? Question is speed with it when descend. Speed, velocity is ours. We have to substitute the value of V. Then V square is equal to U square plus 2S. To find out A, you have to apply the earlier relation. But the acceleration for an acute arrangement like this is 1 by M1 minus M2, like heavier minus G by M1 plus M2 plus I by R squared. I by R squared. By R squared. This is the formula. A is equal to. Now, we are given what is I? I is equal to. First of all, we can calculate what is the moment of inertia of this one. It's equal to basic formula is a disk or a pulley disk. M R squared by 2 about central axis. M R squared by 2. 30 M. Into R squared 0.1. That is the value of I. R is 20. R is equal to 0.1 meter. Y value is given, R value is given. Pascal will cancel out. That's okay. Over here you can say what is the value. A is equal to M1 minus M2. 2M minus M into G by 2M plus M plus 30M R squared by 2R squared. R squared will cancel out. 15M. So is equal to this on calculation G by mg, 1 mg by here 15, 18. Okay, 15, 17, 18 m. M will cancel out. G by 18. Now you got the value of G is equal to A is equal to G by 18. G value is 20. G is 18. So it's written by 18. That is our acceleration. Now here if we apply V square is equal to U square. V square is equal to U square plus 2 into A, G by 18 into S. S is equal to 3.6. This is equal to 9.8 and you get this is equal to 0.2. Get the answer for V. Solve and get the answer for V. And the value of V found to be 2 meter per second. Here the value is equal to 2. This on calculation is 2 meter per second. 2 meter per second. Okay. You can see the calculation again if you want on this page. Next one again. A uniform bar of length 12 cm and 20 lie on a smooth horizontal table. 2 point masses m and 2m are moving in opposite direction with the same speed. V in the same plane as on the bar as shown in figure. This marker strike the ball simultaneously and get stuck on it. After collision, the entire system rotates about the angular velocity omega. The V and omega we have to calculate. Now, before the rod, if you look, the rod center of mass is the center. That is the 6 centimeter. Suppose this is the rod, center of mass is here. But when these particles stuck and collide and stuck here, center of mass, what will be the position of center of mass? Here is 2m. Here is m. Stuck here. And what is the mass of the meter scale? 20m. That is through this. Here 20m. And the length is 12 and this distance is 6. Original center of mass. And here it is 2 and therefore this is 4. This is 2. And this is 4 above, therefore it is 6 plus 4, 10. Our distribution mass, suppose from this, after collision, we want to get center of mass. After collision, before collision, we know center of mass is at center. After collision, where is center of mass? Distribution of mass is, one is 6 meter, 4 centimeter, other is 6 centimeter, 20, other one is 10 centimeter. What is the position of center of mass? That you calculate. After collision, center of mass position is given by m1 expand 2 into 4 plus 20 into 6 plus 1 m given as 1 into 10 by total mass 20 plus 2 plus 1. 20 plus 2 plus 1. R 120, 130, 138 by 23. This cancel out 6. That means center of mass remains the same. Center of mass of this arrangement remain the same as center of the scale before collision and after collision. And therefore, we are going to calculate the next thing, angular momentum conservation. Angular momentum conservation during the collision. That we have to calculate. Now, what is the angular momentum conserved? What is the angular momentum before equal to angular momentum? L before collision equal to L after collision. Angular momentum is conserved after collision. Before collision, there are two moving particles. 2m about center of mass, 2 centimeter. M, V, R, equal velocity V. What is the M, V, R? 2m into V into R is from center of mass 2 centimeter. Plus, and sense is the same, so therefore we are adding. Sense of angular momentum is same, plus M into velocity is V. Velocity for both of them are same. Into perpendicular distance is equal to 4. Equal to after I omega. Angular momentum is constant I omega. Altogether, this is 4, 8 mv equal to I. What is the momentum inertia? Momentum inertia of the rod about central of mass. I is equal to total I. Total momentum inertia I is equal to M, rod about central axis, mass 20 m. M, L square, L is 12. ml square by 12 plus a particle of mass 2m, distance 2 square, plus particle of mass m at a distance 4. This on all calculation. This on calculation is equal to 264 m. Now, angular momentum conserved before collision is equal to after collision. That is equal to this value is taken here, I omega. I is equal to 264 m or 264 m omega. Now from m cancel out. What we have to find? We have to find is equal to ratio V by omega. Then only is not at all. Now this on not doing is equal to what we have to find V by omega. So V by omega is equal to 264 by 8. 264 by 8. That is 33. The answer is equal to 33. Okay. Next question. A circular disc has got a radius R1 and thickness T1. Another circular disc made of same material has radius R2 and thickness T2. If the moment of inertia both are the disc are same, R1 by R2 is equal to 2, then T1 by T2 is equal to 1 by alpha, where alpha is. Now, what the requirement? We have to represent we have to equate the moment of inertia, and in which time we have to write down moment of inertia in terms of thickness and density. Is a disc. This by what is the basic formula for disk about central axis? M r squared by 2. M, a disk, pi r squared, area into thickness, into density, volume into density, into r squared by 2 is equal to pi rho t r raised to 4 by 2. This is the moment of inertia in terms of thickness and radius and density. Here density is same. Now what they are telling, what is given to you? Moment of inertia, both the bodies are the same. So equate the moment of inertia both. Pi rho, what are the word? T1. Thickness T1, radius R1 raised to 4 is equal to pi rho T2 R2 raised to 4. Pi rho cancel out. R1 by R2 is given from this. T1 by T2. T1 by T2 is equal to R2 by R1 all raised to 4. R1 by R2 is equal to 2. Therefore, R2 by R1 is equal to 1 by 2. Is equal to 1 by 16. Now come back. 1 by alpha. Therefore, alpha is equal to 60. Okay, rather simple problem. Next one. A solid sphere of mass 5 kg and radius 10 cm is kept in contact with another solid sphere of mass 10 kg and radius 20 cm. Moment of inertia of this pair of spheres about the tangent passing through the point of contact. That is what they ask. Now this is the situation. And we have to find the moment of inertia about this axis. Solid sphere, if your mass is 5 kg, radius 0.1 meter. Contact another also mass 10 kg and radius is 0.2. This is 0.2 and this is 0.1. Now we have to find the moment of inertia about this axis. Apply parallel theorem of smaller one. Total moment of inertia about the tangent is given. Moment of inertia of the sphere about central axis 2 by 5 m r square. 2 by 5 m is equal to 5. R square is equal to 0.1 square plus transfer that about this axis by parallel theorem m square 5 into distance is 0.1. This is the sphere, first sphere about this axis plus of this one 2 by 5 m is 10. Radius is 0.2 whole squared plus parallel conversion m 10 into distance is 0.2 square. This is that of the second sphere about this. Add up these two. That is the total moment of inertia. And here substitute the numerical value, substitute. I'll simplify this one. The simplification give you the answer 0.63. Based on calculation, the answer is equal to 0.63. Okay. A pulley shown in figure is made using a thin ring and two rods of length equal to diameter of the ring. Over here, this is mass distribution, the ring with the two diametrical rods also there. Rim and each rod has got mass m. Rim mass m, radius is, each one has got mass m. And the diameter of the rod is diameter, length of the rod is diameter of the ring. This okay. Two blocks of mass m and small m are attached to the positive or pulley, which is hinged to rotate freely at a vertical plane with its center. The magnitude of the acceleration experienced by the block A What is the formula for A? I'll wrote down. It's equal to M1 minus M2 G by M1 plus M2 plus I by R square. Now M1, capital M. But now we can, before that we have to find what is the value of I, moment of inertia of the rotating part. That is a rim, the two rods about certain axis. Additive property about same axis. So moment of inertia of this arrangement is equal to rim, mass M, radius R, rim, M R squared about certain axis. M, each having mass, capital M. Radius M R squared about certain axis plus moment of inertia for rod of mass M, length 2R, about certain axis, formula ML squared by 12. So M L squared 2R whole squared by 12 about certain length plus M 2R whole squared by 12. This is the moment of inertia of the arrangement. Then what is I by R square? Then y by I by R square. R square cancel out from all these. It's called M I by R square. M plus 4M by 12 plus here also 4M by 12. The 1 by 3 is equal to 2 by 3 plus M. So now you got the value of I. So I is equal to I by R square. This is equal to, this one calculation is M plus 1 by 3, about 2 by 3 equal to 8 by 3 M. Now substitute here. M1, capital M, minus small m by capital M plus small m plus I by R squared, 8 by 3M. Get the answer. And the answer is going to be this one. Two cars and be each of mass 10 raised to 3 kilogram moving on parallel track separated by a distance 10 meter in the same direction. With the speed 72 kilometer per hour. 5 by 18, 72. 5 by 18. This is the 5 by 18, 10. This is 20 meter per second. This is 10 meter per second speed. The magnitude of angular momentum, so car A and car B, A, and this is B, 20. Magnitude angular momentum of RA with respect to B. This is 10 meter per second. 10 meter per second. This is 20 meter per second. Linear separation, parallel track. Uh, 10 meter. Question is magnitude angular momentum of car A with respect to B. MV, where V is the relative velocity, MV into R. Mass of the body, MVR. Mass of magnitude of the angular momentum of the car A. Car each has got mass 10 raised to 3. MV, V relative velocity, V relative into perpendicular distance. So L is equal to mass 10 raised to 3. In the relative velocity, both are in the same direction. 20 minus 10, that's equal to 10. In the perpendicular distance 10. And get the answer 10 raised to 5. Next question. Two identical rods in kilogram length L are connected as shown in figure. The moment of inertia of the combined rod system about an axis passing through P and perpendicular to the plane of rod is x by 12 ml square, value of x. So we have to find the moment of inertia of this arrangement about this axis. Now there, the moment of inertia additive property, moment of inertia rod about one end, and that is equal total moment of inertia is given by moment of inertia about one end of this rod, equal to m squared by 3 plus moment of inertia about this rod about this axis, transfer that into this. Moment of inertia about this axis equal to m L squared by 12. L squared by 12 plus m S square. M S square. This is the first rod, this is the second rod. This is the first rod and this is the second rod. Add up and get the answer. This one calculation. Now, ml squared by 3 plus ml squared by 12 plus ml squared. That is the this one adding, you get the answer. 17 by 12 ml squared. 17 by 12 ml square. Compare x is equal to 17. A uniform rod of mass m and length L suspended by means of two identical inextensible light string as shown in figure. Tension in one string is immediately after the other one is cut, is given by. Now when you cut one, you can say that it is toppled or rotate about this axis, one hand, this is one hand rotation, due to the gravity force mg. Generated torque. Our torque, the torque generated by the gravity is equal to, and this distance is L by 2. The torque generated is equal to mg into L by 2. This is the torque. But the tau is equal to L. Now what is asked there? Tension in the string. From this you can say alpha is equal to tau by I. Tau is equal to mg L by 2 by I. Moment of inertia about one end, a rod one end, ml squared by 3. ml squared by 3. Will cancel out. 1 L will cancel out. 3 by 2 G by L. That is our alpha. Then A is equal to R alpha. Or center of mass L by 2. Therefore, A is equal to L by 2 into alpha. 3G by 2L. It cancel out 3 by 4G. This is the linear acceleration of the center of mass when you cut one string. Linear acceleration. A is equal to 3 by 4G. Then acceleration is net force. Here the tension is only one string because the other is cut. Tension is, this is the situation. Here tension, here mg. Now it will fall like this. So net downward force, mg minus t, m into 3 by 4g. From this t is equal to 1 by 4 mg. mg by 4, so option is equal to 1. Now this finishes our paper questions from gravitation and system of particles. Thank you. See you next. Good day. Masses are the same, but this is 25 centimeter. That's okay. At 25 meter. 25 meter. 20 become 25 meter. Now what is the work done? Work done is same as the change in potential energy. So we have to find the initial potential energy of this configuration and potential energy final of this configuration. Imagine a unit mass here the force 4m, here 2m, and the effective is 2m along this direction. And here also, over here there is 2m due to 2m, and here there is due to again m and 3m. Due to m here, m is here, and the resultant is due to 2m here. And therefore this force here is equal to G due to 1m, m by r squared. And whereas this force is due to 3m is equal to G 3m by r squared. Welcome, my dear friends. Today in this video we are going to discuss the questions from two chapters, gravitation and the system of particle rotation. Now question number 1 from gravitation, that is there on the board. Three masses 200 kilogram, 300 kilogram, 400 are placed at the vertices of an equilateral triangle, the side 20 meter. They are rearranged on the vertices of a bigger triangle, 25 meter, and with the same center. The work done in this process. Now, earlier, the arrangement we can do like this. It's an equilateral triangle outside a 20 meter. And mass, three masses, 200 kilogram, 300 kilogram, and 400 kilogram. The operation are the same. Question is, we are going to rearrange so that a bigger triangle of 25 centimeter. Now this is transformed into this one like this. Masses are the same, but this is 25 centimeter. That's okay. At 25 meter, 25 meter, 20 become 25 meter. Now what is the work done? Work done is same as the change in potential energy. So we have to find the initial potential energy of this configuration and potential energy final of this configuration and subtract. We get the work done. So the work done. Now we have to calculate for the initial potential energy. G m. Our basic formula is equal to potential energy is equal to minus G m1 m2 by r. The potential energy formula. So it's equal to minus r is same for all of them and therefore minus G by r into adding three terms m1 m2 400 into 200 plus 200 into 300 plus 300 into 400. So G m by r, there are three terms, and out is r is 20. So here you can see that this is 20. This is the initial potential energy of the system. Gravitational constant is given. R is given. Therefore, this is equal to minus gravitational constant 6.7 into 10 raised to minus 11. R is equal to 20 into this term into 10 raised to 4 plus 6 into 10 raised to 4 plus 12 into 10 raised to 4. Final potential energy. Final potential energy, if you do it the same way, you final. This time is the same, this time is the same. Only difference is instead of 20, it is 25. That's okay. For this situation, minus 6.7 into 10 raised to minus 11 by 25. This time is 8 into 10 raised to 4 plus 6 into 10 raised to 4 plus 12 into 10 raised to 4. Now numerical calculation is there definitely, And you can say this is the next part is the work done. Work done, we already told that this is equal to Vf minus Ui, that is the work done. The change in delta U, that is the work done, and work done you can compute from this. Compute from this, substitute this numerical value, and this value on calculation, you can see that on next page if you want. Otherwise you calculate and the numerical calculation. Here the result 1.74 into 10 raised to minus 7. So the option is correct. We can go to our next question. Next page, the calculations are there if you want, but no need of it. But given below are two statements. A satellite is moving around Earth in very close orbit of Earth's surface. The time period of revolution satellite depend upon the density of Earth. Now we have to want to see whether it depend on density of Earth or not. For which we are given the time period like this. T is equal to pi root of R of Earth. Very closer orbit, R is the radius of the Earth itself. G is equal to, we can replace it by Gm by small g. Capital G, capital M by R squared. Where capital G into, this is equal to 4 by 3 pi R cube into density by R square. So this will cancel out, this is the formula, 4 by 3 pi G R rho, that is G value. Now instead of this G in our equation, substitute this value, it's equal to 4 by 3 pi G R rho. And here we can say R will cancel out, and definitely T depend on rho. And what does the statement say? Statement remove around Earth and orbit close to the Earth's surface. The time period of revolution depend upon the density of Earth. That is true. This statement is true. Statement 1 is true. And what about the statement 2? The time period of revolution satellite given close to Earth's surface, where R is the radius of Earth and G is the accelerator due to gravity. And 2.2 RE by G, that is true. For a close orbit, that statement is true. And therefore this one is also true. Both statements are correct. So the option is 4. Both statement 1 and 4 are correct. Okay. Next one. Escape velocity from a spherical planet A is 10 km. Escape velocity from another planet B, whose density and radius 10% more. We have to write down the escape velocity in terms of density and radius. Density and radius must be there in the expression. You know escape velocity, root of 2 G M by R. Now replace M and bring in density and radius. Equal to root of 2 G 4 by 3 pi R cube density by R. Therefore, V escape, these are constants. R cancel out, you can say that proportional to root of R squared rho. Escape velocity depends on R squared rho. Then, in our first case, R is R, rho is rho. In the planet B, radius and density 10%, radius 10% of that of A. Escape velocity from another planet B, whose density and radius are 10% of those of planet A. 10% mean is equal to R2, we can say this is RA. We escape A proportional to root of RA squared rho A. Escape velocity for second planet B proportional to RB squared by rho B. Now VA is given to you, first planet. VA is given to you. Now dividing, this is question number 1. And this is question number 2. 2 by 1 gives 2 by 1 gives you VB by VA, and VA is 10 given to you. It's equal to root of RB by RA whole squared, RA whole squared into OB by rho A. And how much RB? Only 10 percentage. 10 percentage means RB by RA as per the statement. RB by RA is equal to 1 by 10, 0.1. And therefore this is equal to 1 by 10 whole squared into by 10 is equal to this on calculation. This on calculation root of 1 by 10 cube. That is equal to 10 by, VB by 10 is equal to this much. Therefore, VB is equal to 10 the root of 1 by 10 raised to 3. This is kilometer, and convert that into meter per second, because the answer is in meter per second. So it's equal to 10,000 kilometer into root of 1 by 10 raised to 3. And this on calculation, the value is found to be this one. Go to our next question. Net gravitational force at the center of a square is found to be F1 when 4 particles having masses m, 2m, 3m, 4m are placed at the 4 corners of a square as shown in figure, and it is F2 when position of 3m and 4m are interchanged. Then F1 by F2. F1 is the force on the particle at the center. Net gravitational force at the center of a square, at the center here. In this situation, the distribution of masses are like this. The distribution is like this. The force is F1. Now we have to get that force. Here you can see that if you imagine a unit mass here, the force 4m, here 2m, and the effective is 2m along this direction. And here also, over here there is 2m due to 2m, and here there is due to again m and 3m. Due to m here, 3m is here, and the resultant is due to 2m here. And what is the angle between them? It's a square, and therefore at this point the angle between them is 90 degrees. And what about the force? The force is given by Gm by r square. Basic formula. Here 2m and 2m, and therefore here G into 2m by r square. Here our r is the half of the diagonal of this. Suppose this distance is r. This is r. I am telling. This is r. Here this is r. This is then the force here, net force here F1. F1 is, these two forces are identical because of 2m. And therefore what is the force due to 2m G, 2m by r square. Here also G 2m by r square. Angle is 90 degree, and therefore the resultant is equal to root 2. Therefore root 2 into G into 2m by r square. This is our F1 in this situation. In second stage, what they did, they simply interchanged 2 particles. When position of 3m and 4m are interchanged, these two are changed. So we are going to draw the second situation. Here is 3m and here is 4m. They are interchanged. Whereas here is m and here is 2m. Now here you can say that due to 2m, net force cancels. And additionally here that is due to 1m. Whereas here is 4m and this is m, and the net force is due to along this direction is due to 3m. Sorry, 3m. Here is 4m and here is m, and the net is due to 3m. And therefore, this force here is equal to G due to 1m, m by r squared. And whereas this force is due to 3m is equal to G, 3m by r squared. And the angle between them again 90. And therefore, we have to find the resultant of that too. The resultant here is F2 is equal to root of Gm by r squared whole squared plus, because they are mutually perpendicular, plus root of 9 Gm by 9, Gm by r squared. G into 3m, strictly speaking is better, I have to write like this. G into 3m by r squared. This on calculation, root 9 plus 110, root 10 Gm by r squared. That is our F2. Now you know F1 and F2 both are there, and we have to find F1 by F2. F1 by F2 is equal to F1 by F2 is equal to root 2 by root 10 is equal to 1 by root 5. Now the question is, what is the numerator? Compare alpha is equal to 1. Compare alpha is equal to 1. So the option is 1. Initially, a satellite of 100 kilogram is in a circular orbit of radius 1.5 RE. The satellite can be moved to another circular orbit of radius 3 RE by supplying alpha into 10 raised to 6 joule of energy. The value of alpha is. Now, earlier, our satellite is in an orbit, radius is 1.5 RE. And we are raising that to another orbit or radius 3 RE, double. Now, what is the work done? Work done is the change in energy of the satellite in these two situations. And what is the expression for energy of a satellite? Is a bound state, satellite revolution. And they were definitely negative. And the formula, you know, the energy of an orbit, an satellite in an orbit is given by minus G m by 2. That is the formula you may remember. And therefore, in first case, energy in the first case, E1 is equal to minus G m by radius of the orbit is given as 1.5. 2 into 1.5 R. Energy in second case, second orbit is given by minus G m by 2 into 3 R. The radius as a whole is given to you. Now the question is, what is the work done? Final minus initial. That I'm doing G m by R2 RE 1 by 1.5 minus 1 by 3. And this on calculation. This on calculation. The work done on calculation is given by substituting. We are given all the values there. And here R is given. And energy supplied is given to you. Energy supplied is given to you. And accelerate due to gravity is given to you. Now you know acceleration to gravity G is given by Gm by R square. Therefore, capital G capital M is equal to capital G capital M is given by G R square. Is equal to capital G capital M is given by this term. Now that can be replaced, and here you can see what is the value of G capital M is given by small g R squared by 2R 1.1.5 minus 1.3 into M. Now substitute the values. And here alpha into 10 raised to 6. The other part substitute, all the values are there, and everything is given to you. Substitute and get the answer for alpha. And alpha on calculation is found to be 1000. The calculation you can see on the next page. Now it is given like this. And we are given all the terms and get the answer for that. If you want, you can get the calculation from the next page. Okay. So change in the total energy is the work done. That's what we did. Strain, stress, plot the material. A, B, C, D is shown in figure. Which material has got the largest Young's modulus? Why you know stress by strain? But here the strain is on y-axis, and therefore from in this situation the y is equal to strain by stress, and therefore y is given by reciprocal of the slope is equal to 1 by slope of this graph. Which are the following best represent the temperature versus heat supply? Graph for water, range from minus 20 to 120. Now minus 20 to 0 degree, normal case, it is in solid state. And solid on heating, its temperature increases. That 0 degree centigrade, it melts. And if you look, you can see that this is the situation in which that happens. Now when heat is given, temperature increases at 0 degree, it melts. And melting is completed, it is in liquid form. Again, it has heated up to 100 degree. 100 degree it boils, and when boiling completed, the vapor gets heated. So the option is fourth one. Welcome my friends. In this video, we are going to discuss the previous session questions of JEE Main from chapters properties of solids, properties of fluids, and thermal physics. Again, very well enter into the video. The very first question is there on the board. Which are the following best represent the temperature versus heat supplied? Graph for water, range from minus 20 to 120. Now minus 20 to 0 degree, normal case, it is in solid state. And solid on heating, its temperature increases. That 0 degree centigrade, it melts. And if you look, you can see that this is the situation in which that happens. Now when heat is given, temperature increases at 0 degree, it melts. And melting is completed, it is in liquid form. Again, it has heated up to 100 degree. 100 degree it boils, and when boiling completed, the vapor gets heated. So the option is fourth one. Now the second question. You can go to the next page to see the clarification, if any, or mathematical clarification. Physical clarification we already giving. Now two wires A and B made of different materials of length 6 and centimeter and 5.4 centimeter respectively. Area cross section are also different respectively, are stretched by the same magnitude. Our extension is the same under a given load. Load is also same. The ratio of the Young's modulus of A and B is equal to x is to 3. Then the value of x is. Now you have to write down the expression for extension. Extension E is given by FEL by AY. And extension is the same. And here the load is the same. F is a constant. Material length are different. Area cross section different. Young's modulus of A and B ratio that you have to write. Extension is the same. Extension same. And therefore, you can say that Y proportional to L by A. L by A for both the cases. Now, therefore, Y1 by Y2 or Y A by YB equal to LA by LB into AB by AA. Now substituting LA 6 by 5.4 NB into area cross section is 4.5, second one, into 10 raised to minus 5 by 3 into 10 raised to minus 5. And this on calculation, the value is equal to 5 by 3. Only 5 by 3. And it is given that is equal to x by 3. It is given that this is equal to x by 3. And comparing x is equal to 5. So the option is equal to 4. Go to our next question. Come to our next question. 1 kilogram of ice at minus 10 degrees added to 10 kilogram of water to lower its temperature from 25 degrees centigrade. Consider no heat exchange the surrounding. Decrement to the temperature of water. Yes. Other data are given to you. Specific heat of ice, water, latent heat of fusion of ice, everything is given. Now here, we have got water at 100 kilogram water. And 10 kilogram of ice. 10 kilogram. And that is at minus 10 degrees centigrade. And the water to lower its temperature from 25 degrees. Therefore, its temperature is 25 degrees centigrade. Now we are adding this. Definitely ice heated up and at 0 degrees centigrade it melt and the resulting temperature is attained. Whereas the water 100 kilogram falls temperature from 25 and resulting temperature is say T. So the mixture on addition resulting temperature is T. Resulting temperature is 3 degrees centigrade. Now in which ice releases heat of loss, ice melt and it gain heat from where water. And the principle of method of is heat loss is equal to heat gain. Heat lost, heat gained is equal to heat lost. And whom the heat lost and for whom the heat gain. Now you can see that ice heat gain. First of all, it will get heated up. And the basic formula is equal to mc delta theta. Here m is 10 kilogram ice. Specificity of ice is given. Specificity of ice. And it heated from minus 10 to 0. So the rise in temperature is equal to into 10 degree. Then it melts and the heat is required for that. Heat required for that ml. The formula ml. M is equal to 10. And specific capacity, later heat of ice is given 3.36 into 10 raised to 5. Then again, its temperature rises from 0 to T. And then again, it has a heat 10 into specific positive water into T minus. This is the heat gained by water. Heat gained by ice. And heat lost by water is equal to. This is equal to. Water, how much? 100 kilogram m into specific capacity 4200 into its temperature 25 fall to T, but 25 minus T. Only unknown is T. Mathematical part you can verify the next page. And here on calculation, T is found to be. So solving this linear equation and solving T is equal to 15 degrees centigrade. The resultant temperature is 15 degrees centigrade. Question is not the resultant temperature, but they are decrement in the temperature. Its initial temperature for water is 25, now it will become 15, and therefore the fall in temperature is equal to 25 minus 15 is equal to 10 degree. So the option is equal to. Okay. Next one. The mathematical part, if you want to verify, you can scan this page. Next. A soap bubble of surface tension is blown to a diameter 7 centimeter. If 15,000 minus x microjoule of work is done in blowing it further to make the diameter 14, then the value of x is. Now, what is that? The work done to increase its radius. A bubble 7 centimeter. Now change it into a bubble of radius 14 centimeter. Whatever work done, that work done is given to you there. This is that additional work done for this activity. Equate. And from this we can get the value of x. First of all, what is the work done? Work done is equal to change in surface area into surface tension. Since it is a bubble, it has got two free surfaces, you know. And therefore, the change in surface area 2 into because of 2 for surfaces. Surface area 4 pi R2 squared minus R1 squared into surface tension T is the work done. And that work done, the energy given, that is equal to 1015 minus x. Here is equal to 2 into 4 pi 4 into 22 by 7, it is sets in the problem. Here, and what is the radius? And the question is given, radius is given, and here is in joule. Definitely, therefore, it must be represented in this side. So, what is the R2? R2 is equal to 14 centimeter radius. Diameter is equal, sorry. So here diameter is 7 and here is 14. Therefore, radius R1 is equal to 3.5 and here R2 is equal to 7 centimeter. So R2 square is equal to 0.007 square minus 0.035 square. 4 by R2 square minus R1 squared into surface tension. Surface tension is given to you as 0.04 is equal to 10,000. And this is in Joule. And therefore, we are going to say that is equal to, this is the work done for the blowing increase in the radius. And this is equated to work that is you did for this activity, blowing it further. And that is equal to 15,000 minus x. This is micro into 10 raised to minus x. Now next is simply mathematical part, because again it's a linear equation and in which you have to find the value of x. Linear equation. The solution of this one give you the value of x. And x on calculation is found to be 11,304 microjoule. 11,304 microjoule, that is the answer. The value of x solving this, you get the answer for this. It's okay. Linear equation and mathematical help you can get from the next page. A cubical block of density rho b 600 kg per meter cube float in a liquid of density. If the height of the block is h equal to 8 centimeter, then height of the submerged part, suppose this is the liquid and density of liquid is equal to rho e. Equal to 900, and in which a body of area A, cross section A, the height is equal to h equal to 0.8 or 8 centimeter. Float, if the height h is equal to 0.8, the height submerged part. So suppose this much is inside, this is h dash, and the density of the solid is given to you as cubical block of density 600. Now what is the value of h dash? Apply the law of flotation. Weight of the floating body is equal to weight of the liquid displaced. And therefore, weight of the floating body height is equal to h, area cross section is A, volume into density of the solid. Density of the solid is equal to density of the solid 600 into G. This is the weight of the body. Body is equal to weight of liquid displaced. Is equal to, what is the weight of liquid displaced? H dash into A into density of the liquid into G. So A, G cancel out. H dash is equal to H. Value of H is going to be 8. Now you have converted into other unit because the answer is in centimeter. For 8. 8 into 6 by 9. That value on calculation is equal to 5.3. The answer is this much. Next one, 64 raindrops, radius 1 millimeter each, falling down with a thermal velocity of 10, collides to form a bigger drop. The velocity of the bigger drop, thermal velocity of the bigger drop. You know, there are small droplets of radius small r, 64 of them. This is combined to form a large one, and radius is called r. Now, first of all, thermal velocity, principally, you know, thermal velocity proportional square of the radius. V, thermal velocity attained by a body when it falls through a viscous medium, V proportional r square, 2 by 9 r square, rho minus sigma into g by eta. Now, proportionality V proportional to r square. Here, capital R is equal to n raised to 1 by 3 small r. Therefore, radius of the large drop is equal to 64 all raised to 1 by 3 small r. It's called 4r. Now, when it collides to form a larger one, its thermal velocity, suppose I say V, proportional to r square. R square is equal to 4r whole squared. Equation number 1, equation number 2. Therefore, 2 by 1 gives capital V by small v equal to 16. Or capital V is equal to 16 into small v. Small v 10, it is given. And therefore, the value on calculation is equal to 160. Okay. Next question. A brass wire of length 2 meter and radius 1 millimeter at 27 degree is held taut between two rigid supports. Initially, it was cooled to a temperature minus 43 degrees centigrade, creating a tension T in the wire. The temperature to which the wire has to be cooled in order to increase the tension in it to 1.4 T. Earlier it was T. The thermal force generated, basic formula. Thermal force when a rod exceeded the 2 point, there is no tension initially on heating. Definitely it would try to want to expand and hence prevented by or tension is generated. And that thermal force is given by YA alpha delta theta. This is the formula. The thermal force. YA alpha delta theta. In first case, you know, tension was T is equal to Y A alpha material the same. And change in temperature is given. Along the radius at 27 degrees centigrade is held between rigid support. Initially, it was cooled to a temperature minus 43. We try to contract. Tension is generated. Either heat or cold, tension is generated on this stout fire. And what is delta theta? Delta theta is equal to the falling temperature. Falling temperature, there you can see is equal to 27 minus 43. That on calculation is found to be 70 degrees. And delta theta is equal to 70. Now the question is, the temperature to which the wire has to be cooled in order to increase the tension to 1.4. From here you can say 1.4 T equal to YA alpha into delta theta. Question number 1, equation number 2. Now 2 by 1 gives 1.4 is equal to, this will cancel out, 1.4 is equal to delta theta by 70. Or delta theta is equal to 1.4 into 70. (98). Now the question is, this is the change in temperature. Question is, cool in order to increase the tension. We have to find the final temperature. Final temperature starting from 27 minus 98. Sorry, 20, no, not 27. Yes. Initial temperature was 27 minus present temperature. We don't know. Equal to 98. So theta is equal to 27 minus 98. 28 minus 98. That on calculation is found to be minus 71. So the answer is equal to minus 71. The final temperature is asked, not the falling temperature. It's okay. Next. A small metallic sphere of diameter 2 millimeter and density 10.5 is dropped in glycerin and have viscosity 10 points, density 1.5 respectively. Thermal velocity attained by the sphere. Thermal velocity formula is given by 2 by 9 r squared rho minus sigma into g by 8. Standard formula. Now directly substitute the value 2 by 9 into r. Everything in CGS, and the answer is also in CGS. Therefore, you can do that in CGS. R radius is given, sphere of diameter 2, and radius equal to 1 into 10 raised to minus centimeter upon minus 1 whole square. Millimeter is converted into centimeter. Rho, density of solid is given 10 point, metallic sphere of diameter density 10.5. Glycerin 1.5 minus 1.5 into 980 by eta 10 points by 2. Now numerical calculation yields the result, and the result is found to be 2. This value on calculation, the result is found to be 2. So here's 2. Next. Strain stress plot the material A, B, C, D is shown in figure. Which material has got the largest Young's modulus? Why you know stress by strain? But here the strain is on y-axis, and therefore from in this situation the y is equal to strain by stress, and therefore y is given by reciprocal of the slope is equal to 1 by slope of this graph, because here the slope is strain by stress reciprocal. Y is equal to the reciprocal. Now we have to see which one has got the lower slope has got larger Young's modulus. Lower slope is for C. Theta is small. Slope is tan theta is small for C, and therefore the answer is equal to. Next question. When a part of a straight capillary tube placed vertically in a liquid, the liquid rises up to a certain height h. If the inner radius of the capillary tube is density of liquid and surface tension of the liquid decrease by 1%, and height of the liquid in the tube will change by. Now we have to first of all write down the formula for height. And capital rise h is given by 2s cos theta by r rho g. And here what are the parameters in this experiment changes? You can say that the radius changes, density changes, and surface tension changes, decrease by 1%. Then height change in percentage. Simply apply the power rule. Now, percentage change in H is equal to surface tension change, percentage change in surface tension. Here it is in denominator minus percentage change in R and density minus percentage change in density rho. Everything else remain constant. And therefore, this is equal to surface tension decrease by 1%. So minus 1. Minus. Decrease by 1%. Minus 1. Decrease by 1%. Minus 1. Is equal to 1%. Plus 1%. So change by 1%. So the answer is equal to percentage. Option is 1. Simply apply the power rule that you studied in our very first chapter, units and dimension. Now rods xy of equal dimensions, about rods are of the same time. Different materials are joined as shown in figure. The temperature of ends A and F. Here it is 100 degree and here it is 40 degree. Respectively, thermal conductive rod X is 3 times that of rod Y. Temperature at the junctions are the points B and E. That is what is asked. Now, we are going to do a thermal resistance problem. And the distribution of PD is equivalent to distribution of voltage that is studied in Ohm's law. Current analogous to current density Ohm's law problem. PD division rule across resistors. The same principle here, temperature difference distribution over thermal resistors. You know, thermal resistance is given by, thermal resistance is given L by Ka. Here L and K are the same for all of them, but K are different. It is given in the problem. Given the thermal conductivity of X is 3 times that of rod Y. 3 times that of rod Y. And therefore, thermal conductivity X is more mean resistance is less. Thermal conductivity more mean resistance is less. Resistance of X is less than thermal resistance of X is less than that of Y. Because K, it is given that given the thermal conductivity of X is 3 times. Then R of X, resistance of X, I am telling, R of X is equal to 3 K of Y. K of X is 3 times that of Y into A. Where R of Y is equal to thermal resistance L by Ky into A. And therefore, if I am going to say this is equal to R, if this factor is equal to R, this factor is equal to 3R. Now we are going to replace this by equivalent thermal resistors. Here X main resistance is R. So there is a resistor R. And here there are resistors. This is the way. And here it is Y. Y is equal to 3R. 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 Here R. And here is equal to 3R. Now here you can see that 3R series 6R. R series 2R. And therefore, this again you can draw like this. R. Here 6 R1 R2 by R1 plus R2. is equal to 12 by 8 is equal to 3 by 2 is equal to 1.5. So this is replaced by 1.5 R. Then this one is our 3 R. And here the voltage difference means here temperature difference. Here 100, here 40. And the difference in temperature is 60 degree. Now there is a linear distribution of temperature, voltage drop, linear. And here temperature drop is linear. Now what is the total temperature difference 60 degree across whom? 3 plus 4 plus 5.5 R. So across 5.5 R, the temperature difference is 60 degree. Per R, the temperature difference per R is equal to 60 by 5.5. Then, what is the temperature difference across this one? Temperature difference across this one. 60 into 60 by 5.5 into R. 60 into 5.5. 60 into 5.5 into R mean this value. 60 into 5.5 per R, 60 by 60 per R, there 1 R, and therefore 60 by 55 on calculation, sorry. So this is around approximately 11 degree. So the drop is 11, here it is 100 degree, and drop is 11 degree here. 11 degree mean 89 degree centigrade. Here 100 degree, here roughly 89 degree centigrade. Then what is the drop across this one? Drop across this one is equal to 60 by 5.5 into 1.5 per R 1.5 per R 60 by 5.5, then over 1.5, that is half of it, approximately 11 plus 6, 17, roughly 70 degree approximately. So fall across this one is 17 degree. So subtracting, it is 72 degree. Here 72 degrees roughly. Now go through the option and see whatever near our value. Here 89, here 72. So the values are this. So we convert that problem analogous to a resistor in current density. And we can do that more easier way. Okay. Given below to statement. Pressure of a fluid is accepted only on solid surface in contact as fluid pressure does not accept any pressure, still liquid. Wrong. Liquid pressure is there everywhere, all interfaces. So the statement is wrong. This potential energy of molecule on the surface of liquid and compared to interior result in surface tension. That is the molecular theory explained. And therefore the statement is correct. So on 12, statement 1 is false, statement 2 is correct. Fourth one. Next one. The thermal velocity of a metallic ball of radius 6 millimeter in various viscous fluid is 20. The thermal velocity of another ball of same material having radius 3 millimeter, the same fluid will be. And here we can see that here we did the problem, radius changes and thermal velocity be proportional to square of radius, be proportional to r square. So in first case, 20 proportional to 6 square. Question number 1. 3. Thermal velocity V dash proportional to 3 square. Question number 2. 2 by 1 gives V dash by 20 is equal to 3 by 6 whole square is equal to 1 by 2 square, 1 by 5. Therefore, B dash is equal to A dash, wrong. V dash is equal to 20 by 4, 5 unit. So the answer will be 5 centimeter per second. Okay. Surface tension of two liquids having same density T1 and T2 are measured using capillary rise method, utilizing two tubes with the inner radius R1 and R2, where R1 greater than R2. Measured liquid height in the tube are H1 and H2 respectively. Ignore the weight of the liquid above the lowest point of the meniscus. Height H1 and H2 and surface T1 and satisfy the relation. Now, here we are given surface tension of two liquids. This is the first liquid. Surface tension is T1 and the height is equal to H1. Radius is equal to R1. This is the and R1. This is the second tube. Second liquid. Surface tension T2. Height is equal to H2 and radius is equal to R2. It is given that R1 greater than R2. Given that R1 greater than R2. Then, assume theta is the same for both of them. The surface tension T is equal to 2s by ROG, cos theta is taken 1. Therefore, T1 by T2 if you do is equal to S is given by T. Therefore, I'm sorry. S is equal to surface tension T is equal to or capillary H is equal to 2s cos theta by ROG. Theta is taken as the same, and therefore we can say H1 is equal to 2 T1 cos theta by R1 rho G, because they are same. H2 is equal to 2 T2 cos 2 R2 rho same G. From this, we can write T1 by T2 equal to dividing. Question number 1, question number 2. H1 by H2 is equal to H1 by H2 is equal to T1 by T2. H1 by H2 is equal to T1 by T2 into R2 by R. Am I correct? Yes. H1 by H2 is equal to T1 by T2 into R2 by R. Now, you know R1 greater than R2. Therefore, R2 by R1 less than 1. R2 by R1, this factor is less than 1. And if this is less than 1, look at here. This factor is less than 1. If this factor is less than 1, this must be less than 1. H1 less than H2. If T1 is equal to T2. If T1 is equal to T2, H1 less than H2. H1 less than H2 if T1, because this is less than also. This is less than 1. If this factor is less than 1, we can say that if this factor is if T1 is equal to T2, definitely H1 less than H2. And but now if T1 is equal to T2, if T1 less than T2, this factor is less than T2, less than 1. If T1 less than T2, this factor already less than 1. Definitely H1 by H2 less than 1. If T1 by T2 less than 1, this factor is less than 1. Therefore, H1 by H2 definitely less than 1. About H1 by H2 less than 1 means T1 is equal to, if H1 by H2 less than 1, T1 equal to T2, because this factor is less than 1, and if T1 is equal to T2, H1 less than H2. Now look at such an option is there. If you come to this option, if T1 is equal to T2, this is 1. This factor is less than 1, then H1 less than H2. So H1 less than H2. That factor is there. It's okay. By argument wise, we can get the answer. It's okay. Now here water flows through a horizontal tube of shown in figure. The difference height between water column in vertical tube is 5 centimeter. The area cross section of A and B are 6 and 3. The rate of flow we have to find. Now first of all, you know that equation of continuity is maintained, and hence by equation A1 V1 is equal to A2 V2. So A1 here, area cross section is given 6 into velocity there V1 equal to. Here the area cross section at B is equal to 3, 3 into V2. Therefore, now we got cancel out 2V1 is equal to V2. That's number 1. Velocity here V1 and here V2. V2 here is more, twice that here. And by Bernoulli's principle again, therefore definitely there will be pressure difference. Now by applying Bernoulli's principle, we can say that pressure change P1 minus P2 by rho is equal to half P2 squared minus P1 squared by Bernoulli's principle. Applying Bernoulli's principle here and here, we get P1 minus P2 by rho. It is since it is, and what is P1 by P2? And P1 minus P2, the pressure difference. Pressure difference is here is equal to pi rho G. Rho G by rho. This cancel out. Here is equal to half V2. V2 you can write 2V1. Bracket 2V1 whole squared. About 4V1 squared minus V1 squared is equal to half into 3V1 squared is equal to 5G. From this V1 squared is equal to 2 into 5 into CGS. The value is equal to 1000. 2 by 3 is equal to 10,000. Therefore, V1 is equal to root 10,000 means 100 by centimeter per second. That is the velocity, V1. But the question is not velocity, but rate of flow. Rate of flow here is A1 V1. V1 is the velocity here. Therefore, rate of flow is equal to A1 V1. A1 there is given, the area there is equal to 6. 6 into this is a simplification, 2 into 3, 2 root 3 into 100, 200 root 3. So the answer is equal to 200 root 3. And you should yield that value. So, okay. Next question. A gas-based geyser heat water flowing at a rate of 5 liter per minute from 27 to 87 degrees centigrade. The rate of consumption of gas that you have to calculate per second. Take the heat of combustion of gas joule per gram. Specific capacity of water given. Now we want to get the gas flowing at a rate of 5 liter per minute. Water 5 liter per minute. What we require is equal to water flowing out per second. So it's equal to water flowing out per second. Water flowing out of the geyser per second is given by 5 kilogram, 5 liter, 5 by 60 kilogram per second. This is the water get heated up per second is equal to this much, 5 by 60 kilogram per second. It get heated from 27 to 87. So heat required for water. Heat required is going to MC delta theta. 560 M is specific capacity into delta theta, 27 to 87, that means 60 degree. This is the heat required. And who is the supplier? The gas. If dm by dt is the gas burned per second, dm by dt, gas burned per second is dm by dt. So dm by dt gram of gas is burned per second. It is CGS, gram per second. And what is the heat release? Heat of combustion is so much joule. So heat released by this gas is equal to dm by dt into energy per second, energy per gram, pi into 10 raised to 4. This is the heat released by gas. And that is used by water. So equating these two. dm by dt into pi into 10 raised to 4. This is the heat released by gas on burning. Is used by water. 5 by 60 into 4200 into 60. Now from this linear equation, dm by dt can be calculated. dm by dt on calculation is equal to, the value is found to be 0.42. So the option is equal to 4 point. Okay, next one. An aluminum rod and steel rod having same length and cross section are joined to make a total length so much, 120 centimeter at 30 degrees centigrade. The coefficient of linear expansion of aluminum and steel are 24 into 10 raised to minus 6 and 1.2 into 10 raised to minus 5 respectively. Length of this composite rod when its temperature rises from 100 degrees centigrade. Same length and area cross section. Total length is equal to 60. And therefore now we have got, and first one, aluminum rod of length 60 centimeter and steel 60 centimeter. And alpha, the coefficient of linear expansion of both of them are given to you. And rise in temperature, it is raised to 100 degree from 30 to 30 degree. It is heated to, so rise in temperature is 70. The question is, the length of this composite rod at the 100 degrees centigrade. We can calculate the increase in each of them, and that is the total increase. Added with the original length, give you the present length. That's okay. So increase in the delta L, the total delta L on heating is given by delta L of aluminium plus delta L of steel. Delta L alpha delta theta, that is our formula. Increase in length, L alpha delta theta. L 60 centimeter. So in CGS it is given, okay, 60 into aluminium alpha of aluminium is given to you. Aluminium 24 into 10 raised to minus 6 into rise in temperature from 30 to 100, that is equal to 70, plus increase in length for steel 60 into 1.2 into 10 raised to minus 6 into 70. Now numerical calculation. The numerical calculation yield you the value 0.15 millimeter. The question is, what is the total length, composite length? So the composite length is equal to 120 plus. So the option is equal to 120.15. So okay, so that finishes our questions from these papers. Thank you. See you next time. By first law, delta Q is equal to delta U plus delta W. Now we have to get what is the question is in the energy part. Therefore, W is delta U. Now you got delta Q, you got, and delta W you have to calculate. That is delta W is given by happening at a constant pressure, PdV, P V2 minus V1. Because temperature rises by 4 degrees. It is slowly time is there, but rise in temperature is there. Therefore, it's the isobaric process. So process is isobaric. What is the value of pressure here? Put V is equal to 1. V is equal to 1. We get the pressure here is given by the pressure correspond to this location. Here the pressure is given by P. Now, a thermodynamic system is taken through a cyclic process. ABC as shown in figure. The total work done. The total work done here is equal done by is a cyclic process. Work done is the area of the enclosed area. The enclosed area is equal to here. Work done is equal to area of the PV graph of a for a cyclic process. So enclosed by, so area ABC. So half into AC is equal to 3. Half into base area 3 into the other one is equal to Pascal 200. And this on calculation, we can get the answer is equal to 300 Joule. Next question. In the following PV diagram, the equation of a state along the curved path is given by V minus 2 square equal to 4 AP, where A is constant and the total work done in the closed path. Now, in this figure, you can see we have to find this area, which is A dash if I say. The entire area, suppose, is A. Then this area equal to A2. Entire area of this rectangle is equal to A. So our answer is A dash is equal to A minus A2. And we have to find this area because it is a cyclic process like this, a closed path. But to get this area, you have to calculate the area of the entire rectangle. That is A, we told. Then subtract this area enclosed by this curve with the volume axis. That is A2. Our aim is, first of all, we have to find A, for which you know what is the value of pressure here. To get the rectangle, what is the pressure value here? What is the pressure value? To get that, we are given an equation P minus 2 whole squared is equal to, P minus 2 whole squared is equal to 4AP. Therefore, pressure P equation is given by P minus 2 whole squared by 4A. Now, what is the value of pressure here? Would V is equal to 1? Would V is equal to 1? We get the pressure here is given by the pressure correspond to this location. Here the pressure is given by P. That pressure P is given by, put if E is equal to 1. So 1 minus 2 mean 1 square upon 1 by 4. P is equal to 1 by 4. Then at once you can calculate what is the area A. Area A equal to length into breadth. So 1 by 4A into breadth is equal to 3 minus 1. 2 is 1 by 2A. Therefore, area A is equal to 1 by 2A. So first part is over. Second part, we have to calculate A2. A2 is the area enclosed by the PV diagram with the, that is obtained by integral. From where to where? 1 to 3. PdV equal to integral 1 to 3. P is given by this equation. V minus 2 whole squared by 4A dV. This part definitely you can see that 1 by 4A will take out. V minus 2 whole squared. That is equal to, this on calculations equal to 1 by 4A. P minus 2 whole cube by 3. Between the limits 1 to 3. And this is equal to 1 by 12A upper limit 1 cube 1 by 3 minus lower limit minus 1 whole cube. And therefore that is equal to minus 1 by 3. Minus of minus, that is equal to plus 1 by 3. Is equal to 1 by 12 into, wrong. Oh, sorry. Here only 2, because already we take 3. Therefore, this is equal to 1 plus 1. That is equal to 1 by 12A into 2. 1 by 6A. So this area is equal to 1 by 6A. A2. Now substitute here. A dash area enclosed is given by A. We told that A is equal to, where is A? Area A. 1 by 2A. 1 by 2A minus 1 by 6A. The value on calculation, you get the value is equal to minus, the value is equal to 1 by 3. Next, plus or minus. That is from the thermodynamic concept. Based on the thermodynamic concept, you can see that here an anti-clockwise loop. The clockwise loop work done is positive. Anti-clockwise loop work done is negative. And therefore our answer is minus 1 by 3. Because it is anti-clockwise loop. And the work done is negative. So minus 1 by 3. So okay. Next question. When 300 joules of heat is given to an ideal gas, Cp is given 7 by 2R. Its temperature rises from 20 to 50. keep it volume constant. We are given Cp and volume constant. So we require Cv. The amount of gas, and you can see that Cv, we are given Cp is equal to Cp minus 2, minus R, okay. And the value is equal to 7 by 2 or minus R is equal to 5 by 2 R. And heat given at constant volume is equal to NCV delta T is equal to N 5 by 2 R the delta T 20 to 50, that's equal to 30. R value is given 8.3, and this on calculation the value is equal to 623.5 N. And the delta Q heat given 300 joule. Over here you can say 300 is equal to, from this N is equal to 300 by 623.5, and that on calculation 0.48 more equal to 48 millimole. Now the answer is about 481 is equal to 481 millimole. And hence the answer. Ten mole of an ideal gas is undergoing process shown in figure. The heat involved in the process from P1 to P2. I mean, we are asking about what happened here. Is equal to alpha joule. We have to get the heat transfer during that part of the cycle. Here, what is? Now, observing that, you can say that this is happening at a constant volume. Therefore, it's isochoric process. So, our answer part, the process involved during our answer part is isochoric. Delta W is equal to 0 because isochoric. This part is isochoric. Delta W is equal to, therefore delta Q is equal to delta U. By first law, delta W is 0, delta. Now to get delta U, what is our formula? Delta U is equal to E in mu, number of moles, into CV delta T. Now CV is directly given to you. Mu number of moles is given, and we have to find the temperature difference, delta T, during this process. Now, it's an ideal gas, therefore, PV is equal to NRT, you know, or NRT. Therefore, T is equal to T1. T is equal to PV by NR. So here the temperature is T1 and here is temperature T2. Then what is T1? T1 is equal to P1. P1 is given to you 21.7 into 1 by number of moles 10 into R 8.3. Similarly, T2 is equal to T2 pressure is there 30. 30 into 1, volume is the same, by 10 into 8.3. Now substitute here, delta U is equal to 10 into CV given to you 21 into T2 minus T1. 30 by 83 minus 21.7 by 83. Now calculate that, and that is the value of alpha. Question is that the value of alpha is the heat involved in the process B1 to B2 alpha, and this value on calculation get the value of alpha. Directly get the value of alpha. The value on calculation is given by 21. Calculate and get the answer. So, okay, next question. Density of water, 4 degree to 20 degree are, we are given the temperature density at two different temperatures. Since the density is given, you can calculate volume also. Increase in internal energy of 4 kilogram of water when heated from 4 degree to 20. What is the heat required? Delta Q. MC delta theta. MC delta theta. If you calculate EM 4 kilogram, C now this is wrong. The C capacity of water is 4.2 joule per kilogram. That is wrong. Maybe gram, and therefore we are substituting the correct value. No. Remember, this is a wrong statement. Definitely, since water is given 4,200, maybe gram, so 4,200. MC delta theta is given by 4 to 27, therefore 16 degree. 20 minus 4, that is equal to 16 degree. This value on calculation is a huge number. So much joule is the heat given. Now, by first law, delta Q is equal to delta U plus delta W. Now, we have to get what is the question is internal energy part. Therefore, definitely delta U now you got, delta Q you got, and delta W you have to calculate. That is, delta W is given by, it's happening at a constant pressure, PdV, P V2 minus V1 is equal to P, 1 atmosphere pressure, 10 raised to 5. What is volume? Volume we are given density. We are given density. Volume that we are required is equal to mass by density. Mass by density. Mass is equal to 4. Density 998 minus volume. Because volume is equal to mass. Volume is given by mass by density or by 1000 meter cube. That is this value on calculation. The value is going to be 0.8 joule, very small. And therefore delta U substitute here. Delta U is equal to delta Q minus delta W is equal to 268,800 minus 0.8. The value on calculation is going to be this one. Okay, we go to our next question. One mole of an ideal diatomic gas expands from E to 2V isothermally at a temperature 27 degree and does W joule of work. The gas undergo same magnitude of expansion adiabatically 27 degree during the same amount of work. What is the final temperature? I mean, both cases initial temperature are the same, but in first case it is isothermal, whereas second case is adiabatic, but work involved is the same. So what we have to do? We have to equate the work done in both the cases, isothermal and adiabatic. I am seeking the help of the. Now, during isothermal expansion, work done is given by nRT log V2 by V1. Here we can see that ideal 1 mole, so 1 mole R into 300 log V2 double. And therefore volume V to 2V. And this is the value. That on calculation is equal to this much. This is the work involved during isothermal expansion. In adiabatic process, the formula is equal to nRT2 1 minus T2 by gamma minus 1. Now diatomic, and therefore gamma is equal to 7.5, 1.4. Now the work involved in both cases are the same. So isothermal work, this is the value. Adiabatic work, here we substitute only unknown is T2. Next one is substitute and solve the value of T2. And on finding the value of T2, you get the answer. Kelvin, convert that value into degree centigrade because the answer is in degree centigrade, formed to be 56.3. So, okay, we go to our next question. Internal energy of a monatomic gas is 3 nRT. Now, here lies the difficulty. And hence, if you follow internal energy for monoatomic gas is 3 nRT, there is no need of it. Since it is monoatomic, it's at 3/2 RT. That is the answer. But it is given so. If we are going to do the question as ideal, monoatomic as 3/2 RT, and what is the answer we got? Definitely won't agree with this one. We will explain later this. 1 mole of helium is kept. In ideal, internal energy of a monoatomic gas is 3 RT. 1 mole of helium is kept in a cylindrical having internal cross section is equal to 17 centimeter square and fitted with a light movable frictionless piston. The gas is heated slowly. Even though slowly, and there is a rise in temperature, and there it is not isothermal because temperature rises by 4 degrees. There it is slowly time is there, but rise in temperature is there. Therefore, it's the isobaric process. So process is isobaric. The piston move, how much? That is what is asked. Now again, here we are going to seek the. Now, internal energy change. Ideal gas is heated from this to that. Internal energy change is given by number of moles 1. 3/2 R. Here we are assuming the value of 3/2 R into rise and temperature. That is equal to 6 R. The value of R 8 point substituting, it is equal to 49.86. That is useful for internal energy part. In first law, thermodynamics, delta U plus delta W, heating 1, how much is heating 1? 126. So 126 is equal to internal energy plus work done. From this, work done can be calculated. So the work done is equal to 76.14 joule. But here piston move, work done we can calculate PdV. If A is the area cross section, dx is the distance which is moved, PdV is equal to PAX. And therefore, this work done 76.14 is equal to pressure into area cross section is given. P into A into X. X is the distance through which it's moved. From this, you can calculate the value of X. X is going to be 0.41 meter or 48.8 centimeter. But that answer is not there. It is not there. Won't agree with the option they give. The answer can be agreed only if the value of CV we assumed here 3/2 where R, yes. Here instead of 3/2 R, if you write 3, answer will be somewhere near the marked option. And therefore we have to take that. But the difficulty is that helium and monoatomic, generally we start with 3/2. But here you have to use as 3, then the answer will be nearer to the marked option. So, volume of an ideal gas increased 8 times and temperature become 1/4. Initial temperature during a reversible change. There is no heat exchange and there was adiabatic compression. There is no heat exchange of heat in the process. Delta Q0 mean definitely adiabatic compression. Identify the gas from the following option. Now, which is that gas? We know since it's adiabatic, T V raised to gamma minus 1 is a constant. Initially, ideal gas 8 times. Ideal gas increase 8 times and temperature become adiabatic expansion. So, not a compression, adiabatic expansion. Initial volume ideal gas increase 8 times. Initial temperature is T and volume is V. Is gamma minus 1 is equal to. Now, after expansion, what happened? Volume become 8 times. And temperature become 1/4. So, T by 4 into volume become 8 times. 8V all raised to gamma minus 1. So, this can be written as T V raised to gamma minus 1 is equal to T into 1/4 into 8 raised to gamma minus 1 into V raised to gamma minus 1. T V raised to gamma minus 1 cancel out. So 8 raised to gamma minus 1 by 4 is equal to 1. From this, get the value of gamma. And the gamma value on calculation is equal to. The gamma value on calculation is found to be that of a monatomic gas. Gamma value is that of a monatomic gas, that is equal to 5/3. And monatomic gas here you can see that helium. So the answer is 4. So okay, that finishes our this session video. First of all, we have to get an expression for collision frequency in terms of these data. What is the collision frequency? Collision frequency is equal to mean free path is lambda and V is the velocity. And therefore, collision frequency is equal to V by lambda. V by 1 by root 2 pi d squared n is equal to V into the numerator root 2 pi d squared n. The RMS speed of oxygen molecule 47 degree equal to that of hydrogen molecule kept at subatomic. The RMS speed for both of them are the same. It is said that we say what is the RMS speed? V is equal to root of 3 RTPM. And they are the same. It is said that here we say R is a constant, therefore root of T by M is a constant for both of them. Therefore, you can write temperature for oxygen, molecular mass of oxygen, root of temperature for the other one is equal to hydrogen by molecular mass of hydrogen. Hello, welcome. This is Mr. Thomas and Chaithanya Classes, and in this video we are going to discuss the previous session JEE Main questions from kinetic theory of gases and thermodynamics. Very first question is the mean free path of a molecule diameter 5 into 10 raised to minus 10 meter at the temperature 41 degree and the pressure 1.38 in 10 raised to 5 is given. Kb is given. Now, the mean free path, diameter and temperature is given. You know the expression for mean free path, lambda is equal to 1 by root 2 pi d squared n. This is our basic formula. Now in our expression, n is not given. Instead of that, we are given the pressure, temperature. Therefore, n must be replaced by pressure and temperature. And the value n, you know, pressure P is equal to n Boltzmann constant into absolute temperature. From this, n is equal to P by kBT. Substituting here, lambda is equal to 1 by root 2 pi d squared p AB. Now see, and substitute 1 by root 2 pi diameter of the molecule 5 into 10 raised to minus 10 whole square. Pressure is given 1.38 10 raised to 5. Boltzmann constant, sorry, 1.38 into 10 raised to minus 23 into temperature absolute scale. We are given 41. So 73 plus 41, 4, 311, 340. And calculate and get the answer. The answer is bound to be 2 root 2. This is the answer. The mathematical solution give you the answer. So, okay. Next question. A gas certain mass filled in a closed cylinder at pressure 3.23 kilopascal as temperature 50 degree. The gas is now heated to double its temperature. The new pressure is there. And here you know that a closed cylinder means volume is a constant. And therefore, Gay-Lucas law P by T is a constant. So P by T is a constant. This is the basic principle here we are applying. In first case, pressure is equal to 3.23 kilo by temperature is 50 degree. 273 plus 50, 323 equal to modified pressure we don't know P dash by now double its temperature. Double its temperature. Here it was T and the present temperature is the value is doubled and temperature doubled mean it is given 50 degrees centigrade. And therefore, when temperature doubled mean it will become 100 degree. And therefore, this will become 373. From this point, the value of P dash and on calculation, P dash is found to be 3, this on calculation 3730. So that is the answer. So, okay. Go to our next question. Velocity of sound in air doubled when temperature is 0 to alpha degree, the value of alpha. The velocity expression we know depend on temperature. Velocity proportional root of absolute temperature. Velocity is given by gamma T by m. And therefore, V proportional root T. Now, velocity of sound doubled. So, what about temperature? V become 2V. Velocity doubled when temperature become 4 times. T dash become 40. And therefore, the temperature T dash become 4 into 273. Earlier temperature is 0 degree, 273. Kelvin. Now the answer is in alpha degree centigrade. So our answer is minus 273. And the value is found to be 819 degrees centigrade. Next question. Air bubble at volume 2.1 and rises from bottom of a swimming pool of 5 meter deep. At the bottom of the pool, water temperature is 17. Volume of bubble when it reaches the surface, when the water temperature is 27 degrees centigrade. Other data is given there. Suppose this is the, here there is an above air bubble and the depth is given to you, 5 meter. And therefore here the pressure P1 is suppose we say Pressure is P1 at this point. Pressure at P1 is given by atmospheric pressure raised to 5 plus hydrostatic pressure due to 5 meter of water column. 5 meter. That's rho G. So 5 into 1000 into G value 10. This is P1 there. And volume is given there, V1, 2.9 centimeter cube. When it reaches here the pressure is P2 is atmospheric pressure, 10 raised to 5. The question is, and the temperature, sorry, one more thing we have to take into account is the temperature. The temperature here T1 is equal to 17 degree. 17 degree means 290 Kelvin. Here P2 is 10 raised to 5, temperature T2 equal to 27 degree. 27 degree means 300 Kelvin. The question is volume. P2 is equal to what? Yes, no, PV by T is a constant. PV by T is a constant. Therefore, P1 V1 by T1 is equal to P2 V2 by T2. P1 10 raised to 5 plus 5 into 10 raised to 4. P1 2.9. We are not changing the unit because we get the answer, the unit on the other side. PV by T 290. Well, P2 is 10 raised to 5. V2, that is what is asked. The temperature is 300. 300. Now, solving, find the value of V2. V2 on calculation is found to be 4.5 equal to 4.5 cc. Okay. Next question. An insulated cylinder of volume 600 cm filled with a gas at 27 degrees centigrade. Atmospheric pressure. Then the gas is compressed, making final volume 20, while allowing the temperature to rise 77. Final pressure is same problem again. P by T is a constant. PV by T is a constant. In first case, filled with gas 27, 2 atmospheres, and is compressed to make volume while temperature, final pressure is asked. Suppose the answer is in atmospheres. You can get P1 is equal to 2 atmospheres. The volume, cylinder volume is 60. I'm not changing the unit because on the other side we are using the same unit. My temperature, definitely converted into Kelvin, is equal to 300. Is equal to P2 into volume. Final volume is 20, compressed 20 by temperature because 77. 273 plus 77, 350. Find the value of P2. The numeric value give you 7 atmospheres. So the answer is equal to 7 atmospheres. Okay. Come to our next question. You can go to the other page to get the calculation part if you need. 2 boxes contain ideal gases A and B. That their temperature, pressure, and number density are same. So many things are same: temperature, pressure, and number density are same. The molecular size of A is half that of B. Suppose size of A is half that of B, but B double. That means diameter or radius, you can see if dA, this is dB. We can from that data, A is half that of B. Half that of dA by dB equal to 1 by 2. That's it. Mass of molecule A is 4 times that of B. Mass of molecule A is 4 times mass of molecule B, 4 times. By MA is equal to 4 MB. Is it so? Mass of molecule A is 4 times mass of molecule B. The collision frequency of gas is 32 into 10 raised to 18. Then the collision frequency. Therefore, first of all, we have to get an expression for collision frequency in terms of these data. What is the collision frequency? Collision frequency is equal to mean free path is lambda and V is the velocity. And therefore, collision frequency is equal to V by lambda. V by 1 by root 2 pi d squared n is equal to V into the numerator root 2 pi d squared n. Now, in our expression, pressure, etc. is the molecular mass must be involved. And therefore, we have to replace V by means of mass, time. Velocity of a molecule is given by root of 3 RT by M. That is 3 RT by M. Gamma RT by M. Collision frequency is given by molecular root of 3 RT by M. And where M depend on, here what about the temperature remain constant. Therefore, we can say from here, what is M? Is equal to root of 3 RT by Na into M, where M is the mass of a molecule. And here, therefore, we substitute here collision frequency given by substitute for V root of 3 RT by Na into M root 2 pi d square n. Out of this, Tpn, n is a constant, P is a constant, and n is a constant, P is a constant, T is a constant. Therefore, frequency proportional to here we can see that depend on d square, this term, T is a constant, therefore d squared by root m. The variable parameters involved is equal to d square by root m. Now, therefore, frequency of collision frequency of B and collision frequency of A is asked. Therefore, collision frequency of A by frequency of B equal to dividing frequency of A dA by root MA square by dB square by root MB equal to dA by dB whole squared into root MB by MA. dA by dB is equal to 1 by 2. Substituting 1 by 2 square into root MB, MB by MA is equal to 4. Root MB by MA, MB by MA is equal to 1 by 4. It's equal to 1 by root, 1 by 2. Is the frequency of A by frequency of B is given to you, 32 into 10 raised to 18 equal to this much. Now, from this, find the multiply and get the value of frequency of A. Frequency of A on calculation is found to be 4 into 10 raised to 8. 4 into 10 raised. So, this is our answer. Okay. Next question. A cylindrical tube AB of length L closed on both ends contain an ideal gas of 1 mole having molecular weight M. The tube is rotated in a horizontal plane with a constant angular velocity omega about the axis perpendicular to AB, passing through the edge A, shown in figure. PA, PB are the pressure at A and B. Then, since it's a fluid, when it's rotate, due to the centrifugal force, there will be compression or force which is more at this end than this one. And the pressure is not uniform for this gas while it rotates. The pressure is maximum here and minimum here. It is the principle of centrifuge, and this is the gas, that is fine. And therefore, we have to get an expression for that. So imagine a small segment out of it. This is the gas rotating about this axis. Imagine a small segment out of it. If rho is the, and we have to get the value of dm, mass of this small segment, which is at the distance x, thickness dx, and volume A is the area cross section. Therefore, dm, the dm of mass of the gas in this segment is given by A dx volume into density. But density is not a constant, it is a variable one, definitely. Reason I told you earlier. So this is dm. Then what is the centrifugal force due to its rotation? Force is given by mr omega square, and therefore is equal to, this one calculation is equal to m main into x into omega square. This is the df. Then change in pressure caused by these two. dp is equal to df by a. The pressure difference caused due to this force is given by, here I forgot to write a into a. So dp is equal to df by a. A will cancel out. Therefore, dm omega square. dm, I am sorry, there is no need of. Now substitute for dm here. It's better. Substitute for dm. dm we wrote down that a dx rho. A dx rho. A dx rho into x omega squared. This is the force by A. So A will cancel out. And hence we get dp equal to rho omega square x dx. Now, we told that rho is not a constant, it's a variable, and therefore we have to replace rho. Rho can be replaced now by gasification at 1 mole. Therefore, we can P m by rho PV is equal to what? Therefore, rho is equal to Pem by RT. Rho is equal to Pm by RT. Now substitute there. Pem by RT omega square x dx. From this, dp by p equal to omega squared RT x dx. dp by p is equal to omega square. Now we have to want to get the total pressure difference between these two ends. That is obtained by integrating both sides. We get is equal to log b between the limits PA to PB equal to omega squared RT. Where I forget to write anything? Yes. Omega, m is there. M is there. M omega square. So m omega square RT x dx integral between the limits 0 to n. So this is equal to log EB by P equal to m omega squared RT x squared by 2 by L squared by 2. Now from this, take the exponential. Therefore, PB by PA is equal to e raised to m omega squared by 2RT. Now the question is, what is PB? PB multiply PA into, and that on calculation, PA into e raised to m omega squared L squared by 2RT. The option is equal to 3. Next question. The RMS speed of oxygen molecule 47 degree equal to that of hydrogen molecule kept at some temperature. The RMS speed for both of them are the same. It is said that we say, what is the RMS speed? V is equal to root of 3 RT by m. And they are the same. It is said that here V same. In there V same, R is a constant. Therefore, root of T by m is a constant for both of them. Therefore, you can write temperature for oxygen, molecular mass of oxygen, root of temperature for the other one is equal to hydrogen by molecular mass of hydrogen. From this, squaring both sides, TO, oxygen molecule given, oxygen is 47. 47 means 320. 320 by 32 is equal to hydrogen, that is equal to hydrogen molecule kept at so much. Temperature of hydrogen we don't know. This is 2. Cross multiply and get the value. Get the value is going to be 253. Answer will be in Kelvin. Convert that into degree centigrade is equal to 253 degrees centigrade. 253 degrees centigrade minus. So the option is equal to 4. This on calculation. Minus, of course, minus. Answer that you obtained will be in Kelvin. Answer is, but asked is in degree centigrade. Ten moles of oxygen is heated at a constant volume 80 to 40. The change in internal energy in calories. The change in energy is internal energy. Change delta U is equal to m CV delta T. Now here 10 moles. Here m mean number of moles or mu CV dt. But 10 into oxygen. Cp is given to you. Cp is given to you. And therefore, Cv is equal to Cp minus R. That is Cp minus R. That is equal to 7 minus 2. It's equal to 5. Equal to 5 into the change in temperature, that is 30 to 40. And the value on calculation is going to be 500 calories. So the answer here is equal to 500. 500 calories, okay? That is the weight of the floating body. Equal to weight of the liquid decrease. That is equal to L into A into density of the liquid. Rho. Now this can be replaced by directly. Intensity here is equal to I by first case. I1 is equal to 0 by R square. Second case, I0 by 2R whole square is equal to I0 by 4R square is equal to how much time? I1 by 4. Before loading, when it is excited, 8 beats in 2 seconds. Therefore, beat frequency is 4. Therefore, there are 4 beats it by 2, 4. And therefore the frequency of A can be 384 or 376. Now, welcome my friends. Today's video we are going to discuss the questions from oscillations and wave. The very first question is there on the board. Go through the question. Two tuning forks A and B are sounded together giving 8 beats in 2 seconds. When fork A is loaded with the wax, the beat frequency reduced to 4 beats in 2 seconds. The original frequency of the tuning fork B is 380 than the original frequency of A. Suppose this is our A. Suppose this is our A and whose frequency is R, and this is our B whose frequency is given as 380. Now, before loading, when it is excited, 8 beats in 2 seconds, therefore beat frequency is 4. Therefore, there are 4 beats, 8 by 2, 4. And therefore, the frequency of A can be 384 or 376. Now, then it is said that when fork A is loaded, when this is loaded, A is loaded, definitely the frequency must decrease because mass increases, frequency decreases. That means if it were 384, go below that. If it is 376, go below that when after loading. Whereas B remains the same, nothing happened to be 380. In this situation, when they are excited, it is given that 4 beats in 2 seconds. The beat frequency becomes 2. And hence, the frequency of this body now 382 or 378. On loading, you know that its frequency decreases. If it were 376 earlier if the frequency decreases, definitely the value will go below 376. But here the possible value 378 and never go below that. Therefore, this option is not possible. Therefore, the value is equal to 384. The tuning fork frequency is equal to 384. So, okay. Next question. As shown in figure, a spring is kept in stretched position with some extension by holding mass 1 kilogram to 0.2 kilogram with a separation more than natural length and release. Now, two mass system oscillate. Then the time period, what is the frequency? Time period is given by 2 pi root of mu by k. Or frequency is given by 1 by 2 pi in the root of k by mu, where mu is the reduced mass two body system, and mu is given by m1 m2, 1 into 0.2 by 1 plus 0.2. m1 m2 by m1 plus m2, the reduced mass of the system, is equal to 0.2 by 1.2 equal to 1 by 6. Now substitute here directly and get the frequency. Frequency n is equal to 1 by 2 pi in the root of k is given 150 by reducer mass is bound to be 1 by 6. And get the value is bound to be 30. This on calculation, the value is equal to 30. Next question. The speed of original longitudinal wave in a metallic bar is 400 meters per second. The density and Young's modulus of the material are increased by 0.5 and 1%. Then speed of the wave changes approximately. You know what is the relation between y speed of sound and through a medium and density? You know velocity v is equal to root of y by rho. And therefore, percentage error in P equal to half into error in y minus half into error in rho. Error in y it is given to you. Applying power rule. Error in y is given to you 0.5. Half into half minus. The other one is equal to 1%. Sorry, you density and Young's modulus. I am wrong. Half into first one density. Density of bar increased by 1.1, 0.5, that is equal to half. Minus half into density 1%. Sorry, Young's. I'm wrong. Again, I am wrong. I'm sorry. This is wrong. It is equal to half into y. The y 1%. 1 minus half into half. It's equal to half minus 1 by 4. It's equal to 1 by 4% of 400. And therefore, then the speed of the wave. So change in velocity is equal to 1 by 4 of 400 by 100. That is the change in velocity. dV on calculation, this value is going to be 1. And therefore, the frequency become 401. Option is 4. Applying power rule. Okay. Next question. The displacement of a particle executing simple harmonic motion with a period t is expressed as, starting from origin, A sin omega t. Where is the amplitude? The maximum value of the potential energy. So this is the oscillator starting from mean position. Observation start from mean position. The question is maximum value of potential energy at the extremum. So the maximum potential energy maximum at the extremum. And what is the time taken by the oscillator to from here to here is t by 4. But in the answer is given that time t is equal to t by 2 beta is equal to t by 2 into 2. Therefore, comparing beta is equal to 2. It is here distance. Okay. Next question. A point source is kept at the center of a spherically enclosed detector. The volume of the detector increased 8 times. So earlier it was like this. Volume is V. Next case, the volume is equal to 8V, mean if radius of the earlier situation is R, distance from to the periphery is R, then distance from periphery to this one is equal to volume become 8 times, therefore radius become 2R or distance become 2R. Now intensity here is equal to I by first case, I1 is equal to I0 by R square. Second case, I0 by 2R whole squared is equal to I0 by 4R squared is equal to how much time? I1 by 4. And therefore, the decreases by 4%. Intensity proportional, inversely proportional square of the distance. Decreases by 4 times. Okay. Next question. The fifth harmonic of a closed pipe is found in unison with the first harmonic of an open pipe. Ratio of the length of the closed pipe to that of the open pipe is 5 by x. Then the value of x. Now, this is a closed pipe. Well closed. The fifth harmonic, y into V by 4LC. Nominal frequency of a closed pipe V by 4LC. And that is same as first harmonic of an open pipe. Suppose this is the open pipe, L open. Then the first harmonic is given by V by 2 L open. They are same as per the problem. Now we will cancel out. This come 2. And the question is the length of the closed pipe. To LO by LC. If you calculate LO by LC is equal to 2 by 5. 2 by 5. Sorry. The length. The ratio of the length of the closed pipe to that of the open pipe. Ratio of the closed pipe. Oh, sorry. Wrong. I am wrong. This calculation is wrong. The ratio is ratio of the closed pipe LC by to that of the open pipe LO. LC by LO is equal to, we'll cancel out. This will be 2. LC by LO is equal to 5 by 2. LC by LO is equal to 5 by 2. This is 2. This cancel out. Here is 2, 5 by 2. Now the answer is compare with 5 by x. So you can say that x is equal to 2. So x is equal to 2. So that is the option. Again, a simple problem. Next question. A cylindrical block of mass m, area cross section A, is brought in a liquid of density rho and with the axis vertical. When depressed a little and release, the block start oscillating, the period of oscillation. Suppose this is the situation. This is the block immersed up to this H or L. This is height H or the block. This much is inside the liquid. Then standard formula. Standard formula is equal to time period T is equal to 2 pi root of equilibrium depth of immersion by G. Root of L by G. Equilibrium depth of immersion by G. Now we have to find L. Apply flotation, weight of the floating body. That's equal to area into H into density of the body into G equal to. What is the density of the body? Liquid density. So this is sigma, we can say. So this symbol I am changing. Sigma into G. That is the weight of the floating body. Is equal to weight of the liquid displaced. That is equal to L into A into density of the liquid rho into G. Now this can be replaced by directly EM. EM into G. G cancel out. From this L is equal to M by A rho. Now substitute this here. Time period T is equal to 2 pi root of M by A rho G. M by A rho G. And the option is equal to M by A rho G 4. Next question, it one. A simple pendulum of length 30 cm perform 20 oscillations in 10 seconds. The length of the string required to pendulum to perform 40 oscillations in the same time duration. Now in the first case, what is the time period? Time period of the pendulum is 30 cm length perform 20 oscillations in 10 seconds. Our time for one oscillation will be 20 is equal to 1 by 2 seconds. First case T1. In second case, what they are asking? 40 oscillation in the same duration, 10 by 40. So 1 by 4 seconds. That means period is halved. Now what is the relation between time period and length 2 pi root of L by G. So T proportional root L. T1 by T2 is equal to root L1 by L2. T1 by T2 on calculation. T1 by T2 is equal to 2. 1 by 2 by 1 by 4 is equal to root L1. First case oscillation 30. So L2 is equal to what? This will grow up to squaring. 4 is equal to 30 by L2. Therefore, L2 is equal to 30 by 4. 0.75. The answer is equal to 0.75. So again, next. In an organ pipe, Nu3 and Nu6 are third and sixth harmonic frequency respectively. If V6 minus V3 is equal to 2200 Hertz, then length of the pipe. Now it is given that the frequency difference, third harmonic, 3 of fundamental, the other one is only sixth harmonic, 6 of fundamental difference. That is the difference between them is directly given to you as 2200 Hertz. 3F is equal to 200. F is equal to 2 by 3. This is the fundamental frequency. And what type of pipe? Open pipe. Then open pipe, open organ pipe. So this frequency is same as V by, for an open pipe is equal to 2L open. Therefore, 2200 by 3 is equal to velocity of sound is given to 330 by 2 into L. From this, the length of the pipe can be calculated in millimeter. Find the value of L. L in calculation is 225 millimeter. This calculation give you in millimeter. The answer is us. We get the meter, convert that into millimeter, get the answer. Okay. Two loudspeakers, L1 and L2 are placed with a separation 100 meter, as shown in figure. Both the speakers are fed with the audio input signal, same frequency, the constant volume. A voice recorder initially at a point E, at a distance, both loudspeakers moved 25 meters along the line AB. Along the line AB, while monitoring the audio signal. The measured signal was found to undergo 10 cycles of minima and maxima during the movement. Then the frequency of the input signal is so much hertz. They are asked. Now it is similar to an interference experiment. Here we can see that I'm using some other color. Now this is the equidistant point, path difference 0. Whereas from here the path difference is equal to L2B. L2 path is given by L2B. So L2B is equal to 40 and this is 40 and this is equal to 30. Why? About root of 40 squared plus 30 squared. And that calculation yield you the value of 50. Whereas L1B on calculation, this distance, L1B is equal to root of 40 squared plus this. 40 square plus this distance, 25 minus by 20 square. That calculation yield the value 44.6. And therefore, what is the path difference from here and here? Path difference is equal to L2B minus L1B is equal to 50 minus 44.6. That calculation give you that is equal to 0.54. This is equal to 44.6 is equal to 5.4. But it is given that the path difference from here and here is equal to 5.4, and this is the 10th maxima. 10 bands are included here, 10 bands. To have the 10th maxima here, the conditions will be n lambda. Therefore, we can say 10 lambda is equal to the path difference. If lambda is equal to 5.4 by 10 equal to 0.54. Now you got the value of lambda. Now what is the question? Question is the frequency. Once lambda is obtained, frequency f is equal to v by lambda. V is given 324 by lambda is equal to 0.5. This value on calculation, the value this on calculation is 50 hertz. So that is the answer, 600 hertz. So it's an interference experiment. So okay. Time ayo. Two question. ഇത് കഴിഞ്ഞിട്ട് മതിയില്ല, അത് കഴിഞ്ഞിട്ട് പോകാം. We continue. A simple pendulum bob with a mass m and a charge q. Pendulum string has got negligible mass and uniform horizontal electric field is applied. Tension in the string changes. Final tension in the string when the pendulum attained equilibrium position. Earlier, the pendulum was like this. When it is charged one and horizontal electric field is applied, electric field is along this direction, and therefore this reason there are two forces. This is the mg, and here the field force is equal to eq, and this is the resultant of these two. So the tension is going to be root of resultant of these two mutually perpendicular, mg whole squared plus eq whole squared. mg whole squared plus eq whole squared. So option is equal to 4. Next, kinetic energy of a simple harmonic oscillator with the angular frequency the kinetic energy of a simple harmonic oscillator oscillating with the angular frequency. So angular frequency of kinetic energy, omega of kinetic energy given to you 176. Now the question is frequency of the oscillation. But if omega is the frequency of the oscillation, then displacement frequency, the kinetic energy frequency is equal to omega. That's okay. But omega is equal to 176. Therefore, omega is equal to 176 by 2, 88. So the option is equal to 2. Now, two strings A and B having linear densities mu A 2 into 10 raised to minus 4 and mu B 4 into 10 raised to minus 4 kilogram per meter. Length LA 2.5, LB 1.5. Respectively are joined, free end A, B tied to rigid support C and D, respectively, creating a tension 500 Newton in the wire. Two identical pulses sent from C and D and take time T1 and T2 respectively reach the joint, then T1 by T2. Now we can draw, this is the two wires, this is C and this is D, and here this is LA and this is LB. Now tension is the same because they are connected like this, series, and therefore tension is the same. You know velocity V is equal to root of T by M. tension is the same. Next, the time to travel, this much distance. Time is given by distance by velocity. Time. Next one that we have to, and therefore, what is that? The first case, what is velocity? The first case, T1 or TA is equal to distance is equal to LA. By velocity is given by root of T by MA, where MA is the linear density. Similarly, TB is equal to LB by velocity root of T is the same, but linear density is different, MP. And what is asked? T1 by T2. Therefore, TA by TB, T1 by T2 means TA by TB is equal to LA by LB in the root of MB by MA intensity. Now we are given LA and LB 2.5 by 1.5, the root of linear density of B 410 raised to minus 4 by 2 into 10 raised to minus 4. This one calculation is 1.18. So it's equal to 1.18. Now this finishes this video.